I don't know, sort of studying linguistics and psych, and also working with Nathan on some fun HCI projects. Yeah.
Should I be next?
Yeah, go for it.
Or we can just point then to the next person. So my name is Floyd Müller. I am a professor at Monash University in Melbourne, Australia. But I'm also general chair, was general chair at the CHI 2020 event to be held in beautiful Hawaii. So very sorry that we can't welcome you over there. We had a beautiful conference venue with windows, open air next to Waikiki Beach. But then life played something else. So thanks Rakesh and Nathan for organizing this virtual workshop. And yeah, that's from me. Floyd Müller is my name. On my window is Andrzej Romanowski. You would like to introduce yourself next, please?
Thank you. I'm from Poland. And actually, I'm here because of one of my brilliant students who will be probably the next, so Alexandra. And we have a HCI group called Ubicom in Poland, in Łódź, in the middle of Poland. I'm a professor. My background is from industrial design of process tomography systems. And now we are doing a lot of things with context awareness, with sports in HCI, so this is an interesting topic for me, this motor memory. So that's why I'm here. And actually we have another student from our group over there, so Jakub will be probably also somehow. So that's me. Thank you.
So does your student want to be next, Alexandra?
Hi, yes, yes, sure, I can go next. I'm really pleased to meet you all. So I'm a computer science student. It's my 4th year at Lodz University of Technology. Right now, I'm a visiting undergrad researcher at Harvard HCI at Krzysztof Gajos Group, thanks to the collaboration of our both universities. And so right now I'm in Boston. It's 6:30 a.m. So if anyone is in the same time zone, I sincerely say hello. Like my research interests is visual attention, silence of objects and affordances, immersion, the level of immersion in interactive systems, also edutainment, ideation, and the mix of HCI and neuroscience. So that's me. I don't know, I could say more about current projects, but maybe it's not the time.
Just nominate somebody who should introduce himself next.
Okay, so Jakub from our university, can you go next?
So I am Jakub. I'm studying computer science. I am on the second semester. I'm interested in VR development, and now I'm learning about VR development in Unity to make projects in next semesters. That's me.
Cool. Do you want to nominate a next speaker?
I can nominate, I don't know, Dennis Deitz.
Okay. Hi, everyone. My name is Dennis Dietz. I'm from the LMU Munich, and I started my PhD at the end at 2018. So I'm in for 1.5 years now. I'm basically working on a project where we try to improve the performance of goalkeepers, like in handball. And from that idea, I try to develop more into the direction of body awareness and how the importance of motor memory and all these things come together to improve the performance in all like at all in total. And that's why this workshop is very interesting for me. And I hope I can work with some of you guys. So, David, it's your turn.
Thank you, Dennis.
I'm Stephen Villa actually, but my name is also David, so there is always a confusion. I am also from Ludwig Maximilian University, and I started my PhD in September last year. My experience is mainly in haptics and computer graphics, but right now I moved to human augmentation and sensory augmentation. So I'm working with emotion sharing right now. I'm trying to develop a lexicon to encode emotions and then share emotions between people when there is a long distance, for instance, or to get the emotional state of a crowd also. And also I'm working with the balance with vestibular impaired people, also using haptic feedback. And this is one of the topics that I think could fit perfectly in motor memory, this motor memory workshop, also as well as dancing learning, because that's also a topic that I want to explore more, how to use these haptic embodied devices to make easier the skill acquisition, the creation of these motor memories, and then how it impacts when we remove the devices, and if the skill transfer happen and people actually get the knowledge. So basically that's what we do, and those are my interests right now. I will say Sarah is next.
Yeah, hello everyone. First of all, it's nice to meet you all. I'm Sarah Feltaus from the Uni Duisburg-Essen in Germany. And my background is in cognitive systems. Currently, I'm working in the HCI department in our university. I'm a third-year PhD student. My topic goes into the learning effect of electrical muscle stimulation. And for that, I'm more interested in knowing like how people can learn new motor skills through EMS. This is my new approach for my topic, and for that this workshop really interests me to know like more approaches, technologies, or even like psychological aspect of it. So yeah, thank you. Next on my screen is Sang.
Thank you. Nice meeting you all. I'm Sang. Thank you for organizing an amazing workshop. So I'm currently a professor at Zhurich Industrial Design Program, and I have a group called Machine Poetics Group. And we're interested in a wide range of symbiotic relationships we can build with the machines. And what I'm particularly interested in is how we can use like robotics or robotic tools to augment activities that require a lot of motor memory or motor activities, such as painting, drawing, or playing musical instruments. And what are the ways we can weave like machine cognition and machine action processes, like within human processes, in ways that it's not overriding what humans do, but how we can like help us like realize like new insights and inspirations. What else? I'm also in Eastern time, so please excuse me if I feel a little bit drowsy or something. Let's meet you up. So who's next on my screen? I think it's Abby.
Hi everyone, I hope everybody's well. I'm Abby, I'm a postdoc at Université Paris-Saclay in Paris, and by the time of applying for this workshop, I was postdoc at YIRCAM, an institution for science about music and sound. So I was exploring movement learning with sonification. Basically, we transform movement parameters into sound, and so it sort of generates not necessarily the sonic memory, but also help you learn motor skills. I'm particularly interested in this topic also because I move a lot in my life. So I play instruments, I dance, and since a year I'm very much obsessed by aerial hoop. So all I do in my daily life is basically fall into movement learning, and my own experience and shared experience with others in motor learning also helped me reflect a lot on this topic. Also, what I was doing at YERCAM belongs to a larger project called Element, enabling learnability in movement interaction. So basically, we have a bunch of colleagues working on different aspects of motor learning in dance, music, and how do we use augmented feedback to facilitate movement learning. So if you're interested in having a look, I can send you the link, and I'm looking forward to discussing with all of you. So it's my turn to nominate someone, I guess.
Yes.
Yes, please.
So who hasn't talked yet? I see Josh.
Hey everyone, my name is Josh Andres, and I'm part of IBM Research and the Exertion Games Lab in Australia. And my work focuses on augmenting the user's abilities through an integration approach, mostly focusing on an exertion context so far. So what I'm curious to do at the moment is to explore different data modalities to facilitate that integration between the user and the system in different contexts. And that's so far what I prepared for my introduction as I was listening to you all. So I think this topic is super interesting, especially when we think about how we interact with technology without even thinking, and it becomes the technology becomes invisible as you use it. And I'm really curious about how we can leverage this as a design resource. So the next person that I'm going to nominate is going to be the other Sarah on the call.
Hello, my name is Sarah Jane Pell. I'm a former member of the Exertion Games Lab, and I'll be returning to the Monash Exertion Games Lab later this year. I have a background, my PhD was in human performance underwater, and I have worked in human performance in extreme environments from high altitude to deep sea. And I'm interested in the embodied performance interaction at these extremes, but also the human environmental interactions within those spaces. So designing systems for communicating, for capturing and translating that embodied experience across spaces. For example, what could it be like in the future to translate something from Earth to space and vice versa? The next person, I don't know who, I came on a bit late, so I'm not sure if you have spoken, but is Elizabeth.
No, I have not, so all good. Hi, I'm Elizabeth, I go by Liz. I'm actually, my story is very similar to Abby's. I am also on the, I'm a PhD student at Université Paris-Saclay, also on the Element project. So enabling learnability and, what was it? Movement. Anyway, and but I'm more from the gesture focus. So I'm trying to, and I'm also an avid dancer, and so I do that. It's a big part of my PhD. So I'm more looking at how can I integrate these methodologies of dance used for bringing awareness to parts of the body, or awareness to your sensations, or the deeper understanding that dancers trained and use to aid with gesture elicitation methodologies and gestural interaction. I started in November of 2018, so I'm a year and a half in, and it's I'm still defining exactly, but that's where I'm at right now. Okay, so I thought I saw Caitlin had her hand raised for not speaking yet. Is that correct?
That's right. I'd love to go. Nice to meet you all. Some familiar faces. My name's Caitlin. I'm a postdoc at Stanford right now. I won't go into it too much because I'm a participant, so I think I might be having a short intro later. But I work on wearable computing and haptics, leveraging those modalities to facilitate skill training, as well as some motor relearning in the form of rehabilitation. So that's the general overview here. I'm definitely looking to see what other people are doing. As far as nominating somebody next, I think Michinari have you gone? I came in just a minute late, so I'm not sure.
Thank you. Yeah, I haven't yet. So, okay, so it's great. I'm Michinari, and I currently work for the Bandai Namco Group, and I hope you know it's a company for games, famous for Pac-Man, Tekken, many others, and I currently work as a researcher over there. And for my PhD and my postdoc, I was working with Zhurich and mainly on human augmentation, and I was doing work on EMS and related methods based on using electricity onto the human body. And I was always been interested on hacking humans' body, and now I'm interested instead of using electrodes on the body, now I've started going in the body, and now I have several implants in my hand right now. And yeah, I was interested in, I have been working on EMS, and I do have some thoughts on EMS, and I thought it was a good opportunity to share things over here at this workshop. Okay, so I'll nominate right now. So I was a little bit late as well, so I'm not sure. Laia, have you gone? Have you take your turn?
No, not yet. I
Okay.
think I might be the last one. I don't know. Hi everyone. I'm really happy to be here. My name is Laia Turmo-Vidal. I'm a PhD at Uppsala University in Sweden. I'm in my last year of the PhD, and I'm a participant as well. So I guess I'll explain a bit more in depth my research later. But what I'm doing is looking how to use interactive technology to support movement, teaching and learning practices that already exist. So I've been looking at quite some practice right now, like yoga, weightlifting, circus training, and I have been designing an array of different wearable technology, and have been probing this practice with this technology to try to understand how we could actually use technology to support these existing movement, teaching and learning practices. And I'm really interested in this workshop because in my PhD work, I take a very situated ethnomethodological approach to understand what is teaching, what is learning movement. So I'm really, really interested in expanding my theoretical repertoire in this sense, with, I don't know, whatever we are going to be discussing today. And I don't know if, can somebody tell me if, I don't know, there's anybody left? I think I might have been the last.
I think everybody's done, I suppose. Maybe Jacob? Jacob's done, right? Are you done, Jacob?
Yes.
Okay, beautiful. Sorry. Thank you, everyone, for introducing yourselves.
Jacob, have you introduced yourself yet? Sorry.
He did apparently. I think I missed it, perhaps.
It was very short, but yes.
He didn't have his video on. Yeah. Okay. Thanks again, everyone, for introducing yourself. Super glad to have such varied people in the workshop today. So as originally planned, we were supposed to have Steve and Elise do a keynote for the workshop. But unfortunately, Elise couldn't come, and Steve, although he accepted, isn't here yet. So Elise was kind enough to make a presentation for either myself, Nathan, or Floyd to showcase it to all of you. So I am going to share my screen right now, and I'm going to take you through a few slides, after which Nathan is going to take over. And Floyd, please feel free to jump in to slide number 6. I'll let you know, because that is related to both of you. So yeah, give me 1 second. Are you able to see the presentation, everyone?
Yeah, all good.
Beautiful, awesome. So again, welcome to the Mokai Workshop 2020.
Oh wait, 1 second, Rakesh. You got the notes side on your sharing screen.
Oh, okay. Sorry. Yeah, it should be correct now.
Yeah, that's better. Yeah.
Beautiful. Awesome. Welcome everyone again to the Mokai Workshop. And so I'll read out what Elise has written over here. Hi, everyone. Sorry I can't join you today, but I trust Rakesh or Floyd will do a great job at presenting me. I wanted to actually put a picture of her behind me, but I couldn't find a good picture of her. So I'd like to explain to you briefly what kind of research I do and where the idea of the workshop came from. So she's basically been practicing design for remembering for about 20 years. And she's been on as a lead on the research program called Materializing Memories, which she has her research lab in UTS, Sydney. And they're made up of two main components, materializing or making physical, and memories or everyday remembering. You can basically check out more of her work on materializingmemories.com. Some of her research aims include to understand the relationship between media, remembering and forgetting, investigate remembering experiences, designing media products to support remembering experiences. And basically they do this for everyone and not just for people who forget things, like for example, people with dementia. They even do this for healthy people just like you and I. And she also says that it is important to realize that we do not want to enhance memory performance. And basically they just want to support people during their remembering practices. And the long-term vision for materializing memories is achieving transdisciplinary contributions by integrating interaction design with behavioral and social sciences. For anyone interested in this kind of research, like they do with Materializing Memories, you can download a free copy of their report on the website. I can paste the website link in the chat after this presentation. So two of her recent projects that she presented at TEI 2020, which she hosted in Sydney earlier this year, were from Ini Moles and Daniel Ott's, two of her PhD students. I'm just going to explain one of the pictures over here, which is Mole. Like as you can see, three images from left to right. These artifacts have been designed and been created to support everyday reflections. And from left to right, the first one over here is called DOT. DOT is basically a system to represent everyday reflections in the form of visuals. Cogito is the center artifact over here, which is basically created to represent everyday reflections of people in the form of text. And balance is basically an inspiration from nature, and it has two sides, and everyday reflections of people are represented in the form of audio. And these are the systems. You can read more about this in her papers. Floyd, if you want to jump in over here and explain the slide.
Sorry, mic on. Actually, I'm going to talk about that once I talk. So basically, we have a new collaborative project funded by the Australian government on muscle memory. Some call it motor memory, depending on who you ask. For us, it's pretty much motor memory, muscle memory, 6 of one, half a dozen of the other. But yeah, I'll explain later when I get talk to mine. So, but that's a collaborative project that we're working on.
Super. Thanks, Floyd. Nathan, do you want to pick it up from here?
Okay, yeah. So, so in the next few slides, I'm just going to talk about, you know, Elise's background for a bit and a few other projects that her students have done. So, so we got 2 slides of additional reading. You could probably find out. We'll put the slides up on the Slack after this, I guess. Rakesh, yeah.
Sorry,
okay.
yes, I'll do that.
Okay, yeah, all right. So go to, yep, so, yep, here. Okay, so Elise has had, she did her master's, sorry, her Bachelor of Science in Biology, Master's in Human-Computer Interaction, and then she did her PhD in HCI and Remembering, so like quite relevant to what we're doing now. And she was saying, so she says it's around about the turn of the century. That was her, actually, when she was much younger. And she was in a team at Philips Research, and their aim was to build a memory browser. And so in the photo, you see one of the demonstrations they built using like a TV, the touchscreen tablet, which was like really new in 2001. And her supervisor brought this to the table. It was like a tangible interaction souvenir on the coffee table. And here she is saying something about digital personalized media such as digital photos benefiting from materialization. So in this case, tangible interaction. So I guess there's like a tangible version of what's being represented on the tablet. The origins of materializing and materializing memories, my research program, but more about that later. My interest in materializing is also visible through my involvement in the TEI conference. Okay, so yeah, next we have 4 photos. So this is a project by one of our master's students when he did his internship at Microsoft Research in Cambridge. So it's supposed to support storytelling through sharing photos while having dinner. So it's a gesture-based interaction where you don't have to touch the device. Okay, and then in the next one, we got, so this is StoryShell. So this is a bespoke device that was created for a woman who had lost her teenage son. And so when she holds this device, she can listen to stories told by her friends in a closed Facebook group about her son. And then the last one is a PhD project by one of her PhD students, so Daniel Heron, and is currently under investigation, and he works for Facebook in London. And so in this, there's 13 participants, and in doing semi-structured interviews in their home, they aim to understand which digital possessions played a role in the in interpersonal. So I think it was like relationship, like couple relationships, and their breakups. And so they wanted to find out like which digital technologies like sort of played a role in their breakup and sort of how they were involved in that. And so they learned many things. One thing is that people are connected in more ways than they could have imagined, and that decoupling is very difficult, and that the perspective often changed completely after the breakup. So shared digital possessions included things like images, chat histories, videos, emails, social media posts, metadata, text messages, and shared accounts. And yeah, so that's pretty much it. There we go on the slides. So I guess take it back to Rakesh.
Awesome. Thanks so much, Nathan. And that basically ends Elise's keynote. And at this point in time, I think we can jump to the participant presentation, unless Floyd, before that kicks off, if you want to speak.
Sure, yeah, because I had prepared a little exercise I thought I'll do instead of slides, because I wanted to excite you about the same thing that I'm currently excited about. And let's see how that works. I haven't done that before. So let's see if this works. So you heard about Elise, right? And Elise is very interested in memory. I'm personally very interested in the human body, like a lot of you are, in particular exertion activities. So muscles are very important for me. And we thought, what happens when we combine these two things, memory and muscles? And then, therefore, that grant that I mentioned, we received investigating the use of interactive technology to support muscle memory or motor memory. And I thought we do a little exercise, if you can please play along with me. For that, I want you please, turn your video on, which a lot of you already have, and turn your microphones on. So let's see if that works. So it goes in a complete Zoom exercise. It's only going to take a minute, right? But please be with me. So what I want you to do now is open Word or any other word processor that you are familiar with, please. And you're going to come back to Zoom in a second. All you need to do is listen to me now and open Word or anywhere you can type. Notepad, doesn't matter. Anything where you can type, right? So, and I'm going to dictate you a sentence now. And I want you to put your hands over your keyboard. And I want you to type the following sentence, but I want you to close your eyes. Because we've got the video on now, I can actually check. So close your eyes, right? You know where your fingers are, you know where the keyboard is. So it should be no problem considering that you do that every day, right? So I want you to type the quick brown fox. Oh, you know the sentence. So the quick brown fox jumps over the lazy dog. The quick brown fox jumps over the lazy dog. Yeah. All right, now open your eyes and have a look at what you typed there.
It's actually correct.
Considering you type, you know, every day, 8 hours or however even longer if you're a PhD student, you seem to get some things right? So I assume for most of you, it kind of was okay with that. Now close your eyes again. Close your eyes again. Close your eyes. And now, instead of putting your hands over the keyboard, I want you to now put the hands on your back. So put your hands as far away from the keyboard as you can, but keep your eyes closed, please. Keep your eyes closed. So because your microphone is on, I can hear you, right? And I'm going to ask you a question now, and whoever knows the answer can just yell it out as quickly as possible. There's going to be a couple of questions. So whoever thinks they have it, just yell it out. All right. So just put your hands away from the keyboard as much as you can. And I'm going to ask you, you have just written a sentence that contains every letter of the English alphabet. So the quick brown fox jumps over the lazy dog has every letter of the alphabet. And I'm going to ask you, I'm going to tell you now a letter, and you tell me what is on the left of that letter on your keyboard.
Oh.
J. What's next to J on your keyboard?
L, K, L.
No.
H.
To the left of H, correct. Keep going, keep going. What's next to N? N for North Pole. To the left of N.
N.
B.
B.
Correct, much quicker. Next one is, what's to the left of O for Oscar?
I.
Very good.
I.
What's to the left of L for Lima?
K.
It's like the bracket thing.
K, correct.
K.
All right, thank you. So you can open your eyes again and go back to your keyboard. So thank you very much. So basically, thank God that exercise worked. So, so there's two things that are going on there, right? I'm really excited about. I'm not claiming that I understand fully what's going on there, but I know a little bit now, right? So one thing is we are really good in using the keyboard even without our eyes. because we've got this, what I now call muscle memory or motor memory. So we can do a sequence of things quite good, and we can learn that and train that. But then there's also this other thing where we have this, so the one thing we call procedural memory, and then there's also declarative memory, which is the thing where I ask you which letter is next to it, which is a very different thing, even though it's exactly the same interface that we are using, right? So trying to figure out which letter is next to K seems to be a different process, and even harder than just typing the letter which is next to K. And there's technology that helps us to do the first thing, right? There's lots of training programs, for example, using gamification to train you how to type faster and learn that procedural memory. And then there's also, memory apps that teach you how to do this other type of memory, which is like remembering which letter is next to one. And Elise and I kind of thought maybe there is now new systems to be developed that help us if we have problem with one, why don't we just engage with the other to figure that out, right? And you probably have that when you are trying to remember a password or your PIN number at your ATM, and you can't remember your PIN number at the ATM, but then you kind of start putting your hand onto the keyboard and you start kind of typing to kind of trigger your declarative memory by executing some procedural movement in order to trigger something like getting this memory process to work. And we haven't really found much technology that supports that passing the recall of memory acts from one to the other using the body. There's lots of anecdotal evidence from the medical domain. For example, when people who have dementia can't articulate their way home, they don't know how to find their way home, but then it's been found out that when they actually let them just walk, they end up at home. So you can't articulate how to get home, but you can actually walk home. And there's a lot of anecdotal evidence of similar things happening. We're just really interested in if there is the potential of interactive technology to support with that, getting our muscle memory or motor memory to help with tasks that bridge these two seemingly separate domains, such as figuring out which keys are on which side of other keys on your keyboard. So thank you very much for playing that along. That was my little exercise as an introduction into our research. Thank you. Thanks for playing along. Back to Rakesh.
Thanks so much, Floyd. That was super fun. And yeah, it is just awesome. So as we are running a little ahead of schedule, should we start presentations from our participants? And I actually have a list.
Questions? Sorry, I should have asked. Like any questions?
Oh yeah, sorry. Any questions for Floyd?
Otherwise, yeah, we can go into presentations.
Maybe just a comment. I was thinking.
Yeah,
sorry, I just jumped in.
No, go for it.
Yeah.
No, I was just thinking maybe there was something more to consider with the example of the keyboard, which is we have been exposed to this layout and we have a lot of visual information in relation to the keyboard, right? And in other cases, there is no visual sort of instruction or define a space to perform those motor movements. So those motor movements are fully embedded in the body when you start doing the practice of movement without necessarily needing any visual information to connect the two type of inputs, let's say.
Yeah, there's probably some to it. Yes, absolutely. That should be part of the investigation. Yeah. Sorry, Abby, you had your hand up there, please.
Yeah, I just want to follow up what Josh just said. I think the exercise is a little bit unfair just because typing is kind of an over nerd task. We spend years and years typing. So it's a bit different from comparing to people with dementia and having different types of memories stored in their memory core in a way. Because there's a lot of evidence in psychology, especially different feedback for movement learning, and they talk about the visual, audio, haptic, and what type of feedback are you providing feedback for the movement itself, or are you providing feedback for the errors, or when to provide feedback, because if you provide too much feedback, people would become dependent on it. So I think for typing, we are more like, first of all, overtrained, and also we move away, especially for the, how's this called? It's a kind of skill that you train typing without looking. Yeah, so I think it's probably a little bit different from, to put these two cases together.
Correct. Yeah. So I was trying to figure out a task we can all do together. So yeah, I was using a bit of creative freedom there. To use that. Yes, absolutely. Yeah.
But I think it's very interesting because it served as an artifact for discussion and speculation, and so actually that's very interesting as a starting point, right? So.
The goal was just to show that we all seem to be doing that every day. In maybe not, yeah, it's definitely not the same case. And this project is not about dementia, but I just that example is somebody told us who does a lot of dementia work, and that kind of stuck in my memory. But the example with typing or keypad, your ATM entry is one thing that I think we all had encountered. So there seems to be something going on about us learning certain movement skills and recalling them, but then doing different strategies, and that connecting these different strategies with technology, I think, is underexplored.
Agreed.
Yeah,
maybe
I think it was less. Sorry.
Go on.
Me?
Sure.
Yeah, I just had this thought about like comparing typing or on keyboard and comparing playing a piano or a keyboard, like for example, because I used to learn how to play a keyboard for in high school, so I wasn't a child, so it was like quite hard task to do. But I also did like this exercise with like closing my eyes and playing on the piano, and it was much easier. I think it was probably maybe due to having this feedback in form of a sound, but it was much easier to just use my fingers and play with my eyes closed than typing on the keyboard. I was like so bad at this right now.
Yeah, I know like Caitlin has done a lot of keyboard, like music keyboard work, and she actually gave me some of the ideas we are using, like because we don't have a keyboard, like a music keyboard in front of us, only a computer keyboard. But I thought that's one thing we can all try out. So thanks, Caitlin, for that.
Thank you, Floyd. Actually, I'm very supportive of your idea. In my presentation later, I think I'll provide a nice segue to what you're investigating right now, because as part of my thesis work, where I investigated haptic training for motor skills, I found that people were able to extract declarative information when they were trained on motor actions which were associated with declarative information. So it's basically leading to the question, which I found in my thesis, of this association of motor training and potentially utilizing that to have declarative information training. So I actually think this is a very ripe area and very well associated, and I think that demo was relevant.
Yep,
Thanks, Caitlin. Awesome. Anybody else has any questions, thoughts before we move on?
I just have one last point related to what Alexandra just said.
Yeah.
I think, I don't know if you're aware of this attentional focus notion, because in psychology, they talk a lot about what do you focus on when you do movement? Do you focus on the movement itself, or do you focus on the outcome of the movement? Which in playing piano case, the outcome is the sound. So I think there is a bunch of literature on which type of attentional focus contributes to movement learning itself, and also how you perceive your progress. That might be something interesting to look at.
Yeah. Thank you.
Awesome, thanks. Beautiful. If anybody else does not have any other thoughts, we can proceed with the first presentation from Sarah. Sarah Falteis,
Yeah.
am I pronouncing it right?
It's Sarah Falteis, yeah.
Okay.
I will share my screen. It's 3 minutes thing, so it's really a fast presentation. I will just present an example. But before I present, I think Sarah Jane had a question, right?
It wasn't really a question, it was just a comment, and I was just typing to Floyd directly.
I'm sorry.
But I'll say it out loud to everyone because it might be interesting. But it reminded me of, I've been, in quarantine and watching spy movies, and there's a lot of training that we do in extreme environments so that as your performance is under duress because of the external stresses, you can still operate with this embodied learning knowledge. This kind of motor memory action kicks in, and you don't have to necessarily cognitively catch up to that. And similarly, I was just thinking about spy training, if you like, and people using codes and signals. They don't necessarily have to know it or understand it and be able to recall it, other than being in a situation where that time, place, space interaction coincides to bring out that motor memory in order to perform a task. So I think what you demonstrated was the difference between something that can be learnt or embodied at one particular level, but you are asking us and challenging us to see if cognitively we could match the two. And that's kind of nice. It's interesting.
So I watch more spy movies. Good idea.
Yeah, well, why not? It's research.
Yeah, so, and does anyone else have any comment or question to Floyd before I start? Okay, so I'm gonna share my screen with you, and yeah, 1 minute. Yes. No one can see my slides, right? Yeah, I think now.
Not yet.
Now?
Coming up.
Yeah? Okay, so for now, I'm just gonna present a quick example or a quick project that we're currently working on in our lab. And the project goes into examining the result of teaching someone or improving the performance of a motor skill for beginners. And for that scenario, we chose the golf playing. And in this, it was only a scenario because then you can just kind of generalize more the results and apply it to the more motor skills or more scenarios. And in our example, it was golf playing. And for us, we just mounted this is a scene of the overall setup. So we had an OptiTrack, and we had players, and we added the EMS pads to the muscles. I'm going to show you which muscles now. And then we trained them a bit to just shoot the ball towards the goal. And we are using evolutionary algorithm, which helps us to define the best, something called fitness value, which helps us adjust the arm angle. And then we made them test 3 conditions. So this is the muscle that we used. And it's basically the muscle which you use to rotate your arm. It's one of the, so you have several muscles that you can use for this purpose, but this one is more of clear one or to reach. And we asked the user we asked the participants to do, to shoot the ball 10 times in 5 conditions. So we had them one time to do it freely. And one time we asked them to do it with only by activating the dominant hand, and they can seize the goal. One time we asked them to activate it, we activate both hands. So we kind of induce the electrical muscle stimulation to both the dominant and non-dominant hand, and they can still see the goal, so they have the chance to subconsciously correct their arm. And we did the very same thing with while they were wearing the VR glasses, but nothing, like do not see anything, so there was nothing displayed in the VR. And yeah, and we asked them to do that like in each condition 10 times, and our goal at the end was to see, so now we have this condition where they are free to move, we have this condition where they were augmented, so this is where they have the visual input and they can shoot the ball themselves, and then we have this condition where they actually were like activated, so they were not augmented, rather activated, so we were 100% responsible for the movement. And our results indicated that actually it was a non-significant result, but our results indicated that they were best when they were augmented. So when they had the vision, it was the best accuracy. The worst thing was with the no vision, so the activation when we were responsible 100% for for the movement. And one other insight that we got from this study is that people who were really or were slightly better in the free condition, they were worse in the augmented one compared to the people who were really bad in the free condition. They got improved with the augmented one, or yeah.
Sorry, can I just ask, sorry, what's 7 and what's 0?
A 7 and a 0 is the angle of deviation. So we measured this angle. So we measured so we had an alpha which indicated the optimal angle, and then we measured the angle to like which they actually shoot, and the 7 degrees and the 0 is like the angle of deviation. And they recorded the best, so the least angle of deviation was recorded in the vision condition. Yeah, and I think it's just like I wanted to present this so that we can maybe further discuss it, or if anyone has insights to what could be improved or what went wrong, because I've been like thinking about it more and more, and we revised the evolutionary algorithm, and we revised like the performance of the people, and it was really inconsistent. So there was not a general observation other than this of the people who were good and bad with the free condition. Yeah, that would be like, this is one of the studies that really like I'm thinking a lot about it, but we have other studies that goes in the same direction as well, but sometimes in VR, sometimes in like providing different visual input to the user and trying to make them learn something, but these are only ongoing ideas in our lab. Yeah, thank you. I will stop sharing. Yeah.
Thanks, Sarah. That was really awesome. I just had one question. When you showed the first slide, the actual augmentation of the system, how did you? How was the training? You know, what was the training? Yeah, how was training done?
So it depended on the evolutionary algorithm, which we don't have certain number of shoots that was done. It was based on the evolutionary algorithm. Whenever it decides that, okay, we reached the best, like it's kind of trials and you keep doing it. And and each and every time you measure the angle of deviation based on the OptiTrack measurement, but this is only for the training system. And then at some point, there's no longer an apparent improvement in the angle, like in the performance. So at some point it just, okay, I tried different values and now I know that this value, this X value would do the best. Now I stop the training. So it's a decision made by the algorithm.
Okay. Okay.
Did I answer your question?
Yes. Awesome. Thank you. Does anybody else have any questions for Sarah? Comments for Sarah?
Can I just ask, like that was, so obviously putting in golf, did you pick that because it was really easy to do EMS on that wrist, which is important for putting? Or was, like, which one was first, the EMS or the putting?
The putting.
Okay.
So we thought about the scenario first. And because I can guarantee you that like having this kind of fine-grained motion generated by the EMS, it's not that easy. It's not that easy, especially that we do the calibration manually, so we don't have anything like the glove that helps you detect the EMG and then you induce the same current in the same position. We don't have that, so we do it manually. And for that, it's kind of hard to detect the values where you can just rotate the hand. It's kind of tricky. Yeah.
And so you said it wasn't it wasn't statistically significant.
No.
How many people did you have? So it's out of curiosity.
I had overall 14 participants.
Sorry, say again?
I had 14 participants.
14, okay.
And what was the split up? Because you said that some of them were experienced and some of them weren't experienced. So is there like a split up?
We asked everyone who had never played golf before to participate in the study. And it was like, yeah, some people were just good in shooting and others were not good in shooting. It's like.
And how did you come to this scenario, like putting? Like, why didn't you choose like table tennis, for example?
I don't, like, there was something like we were thinking about a scenario where people would need to be precise and it does not need a lot of motion. Like, it's like minimizing the number of muscles where we have to control to reach a certain output. That was the idea.
Okay, cool. Awesome.
Yeah, this may not be very related, but I had a very similar like statistical like chaos when I was working on a robotic guitar system and testing it for learning. And I also recruited people who never played the guitar or like play 1 or 2 times only. But the thing is, some people are just much faster in like learning something. Some people are not. Like it can be because some people have better pitch, better understanding of rhythm innately, or just have better finger muscle training because of whatever they have done like in the past. So what I'm doing now in the current study, which seems to help, is sort of like find a way to offset how difficult the task is a bit, like as long as it's fair for the user study, so people like experience similar level of challenge for that specific task that you're using. Because like regardless of condition, some people might just feel everything's easy. Some people might think like everything is very difficult, unless you're tracking the change within the progression, if that is applicable in your user study. Yeah, but yeah, that's my 2 cents.
For me, at some point, I thought, okay, maybe the users just think of it as a new technology, and some people actually do fear EMS. So they were just, my feeling is that they involuntarily affected the motion. So they were not super relaxed and just letting the EMS control their hands. That would be my
comment.
Yeah.
Because actually for 1 year we are trying to publish a paper for augmenting golf for beginners. And we are doing some different kind of feedback, auditory, visual, and actually we talk with coaches of golf, and it seems that there are so many variables that it could be difficult to assess. Actually, if you are trying to make research on what you are expecting to research, because actually the golf coaches say that there is a full posture that is really important in golf playing, especially at the beginning. So the angle of your knees and so on and so on. It seems that probably you did a very narrow study, and maybe you have to consider much more variables in your study. This is my feeling.
Okay, so we tried the study 1 time before it, and for that we took into consideration 2 variables, not just the angle, but also the force. And for that, at some point, we realized that it also differs, and it does not work. Like, we cannot proceed to detect or adjusting more than 1 variable, except when we are sure that at least 1 of them is controlled. So it was just like a sequential thing. So I definitely do agree with you. If we want to provide a whole system that would augment the human performance, we have to go on a bigger scale. But the problem is that within the first step, it was already kind of we're not sure if we should proceed in this direction.
Okay.
Yeah, but I definitely do agree with you. There's a lot of variables in there, and it's kind of tricky at this point to just control them.
The question is, if you said that you have an optimal angle, and if it's really optimal, this is maybe the source of you know, of the error or the insignificant difference between the results. Yeah.
I agree with you. I think there's probably a way of articulating what the optimal angle is for each individual body and body bias or action bias. So somebody who has a history playing other sports that might hold a bat or a handle or of some kind might have a particular bias on the way that they grip, for example. And I think understanding that rather than looking at bodies as a whole might be really helpful.
That's really nice. You can do that. Thank you.
I'm sorry, did you validate that the EMG was actually producing a difference in the angle, or was it just an applied amount of current that you used?
No, the EMS in the training part where we used the evolutionary algorithm, it was first we had to calibrate the maximum intensity for each participant. And this maximum intensity was given to the system, so the training system, as an initial value. And they used this initial value to calibrate the performance for each participant. So we had a 45 minutes of test, like calibration or training part for the machine at the beginning. So each and every value varied from one participant to the other. It was really individual, like personalized.
But wasn't the dependent variable you were really looking at was the angle of the rotation of the forearm? Is that true?
Not the angle of, like, yes. Yeah, actually, yes. Yes, it is.
But was it validated?
Yes. We did that because
using 3D motion capture or what?
Yeah, OptiTrack. That was this like the part where the system calibrated the values for each participant.
Okay.
Yes.
Awesome. Thanks so much, Sarah. Unless anybody else has any other questions, we can move on to the next presentation by Dennis. Oh yeah, he's there in the middle.
Hi. Okay. Let me just start the presentation. Just a second. Oh, fuck. I hope you see the right screen.
Yes, yep.
Yeah, yep.
Yeah? Okay, good. So I would like to share with you like two ideas or two things that are for me now important and combined together somehow. So as I was already mentioning, I'm working on this project where we try to build a machine with industry partners. It's financed by the German government. And the idea is to improve the performance, because at the moment, the training for handball goalkeepers is like that they really use the whole team to throw them balls into all directions, and then he can try to catch them and avoid that they make a goal. And for this project, my main task is like designing a user interface, which is not interesting for us here, but I guess the gamification approach and also the gesture control. If you imagine we have this machine, it's standing at least 6 meters far away from the keeper, and it's throwing balls at him. So there is this one task where he should interact with the machine to, for example, stop the machine or start a new training session or start a previous training session and things like this. So first of all, I have to define functions for the machines. You just have to imagine it's like I'm standing in front of a whiteboard and that's basically the task. Build something that works. And so the gesture control is one big part where we have to find out what kind of gestures are important for the keeper or what would be useful to use. And then what comes up to that is like, how can we teach these gestures and how can we make sure that he is immediately or that he can do these gestures immediately. Just imagine the ball comes and he wants to stop it. There has to be, for example, a stop gesture where the machine also immediately knows, okay, I have to stop right now and not in 5 seconds, because then the next ball could be thrown and his attention is already gone. So that wouldn't be good. So this is one thing, how we could implement this into the machine and into that kind of setup that he knows what kind of gestures he might use. And from that project, I started to realize, okay, I should also focus more on what's important to learn here. Like, what does the machine train on that person? Is it like reaction time? Is it coordination and so on? And with that, I would like to share something. Where is it? Where can I change it? More about me. So I can juggle and I can also walk on the slack line, and this is my approach to try to do both at the same time. And I think this also relates to the handball goalkeeping thing, because you have to be aware of what your body is actually doing, and then you can like, yeah, act appropriately. So for example, if you try to stand on the slack line for the first time, you will probably notice, or what I mean, not stand, you try to stand up on it. You will notice that your leg is like totally wobbly. And I just figured that it's not because you don't have the muscles. It's because of your muscles don't know how to handle an unstable ground. And with that, I'm actually also trying to build a system in virtual reality where we can train these things. I also have an idea for the juggling, but that's something else. And yeah, I would like to work on these two things. If you have any ideas or recommendations, I'm happy to hear. That's basically it.
Thanks for the presentation. I was just wondering, with the goalkeeper exercise that you were looking at, probably, I don't know if this is true, the reaction time, but there might be another opportunity to think about the movement technique, right? Because this is something that professional athletes really work on. So imagine a goalkeeper learning how to handle high balls or low balls, or using their legs or using their arms, or doing a one-on-one when the striker is coming. So that also involves a lot of movement technique in relation to the goalkeeper training.
Anticipating the ball.
Sorry?
Anticipating the ball. Like, I think for a goalkeeper, that is the most important thing. So
of course, so for what I've learned from professionals, they know where the ball is going to when the person who's throwing it is doing the first step. Then they already know where he will throw it. And that's so amazing, because like, how should they know this? And somehow they do. And if you imagine now you have a machine that's not doing a step, it's just throwing the ball. So the question is then, how can this improve the goalkeeper, or is it really helping or not? Or what would the machine need to like really simulate a human? Like, is it enough to put on a screen to just show, okay, he's doing like a swing ball and so on, or yeah.
And did you, on the approaches that you mentioned, is first is this machine giving you this information and the balls and the signals, and you also mentioned you wanted to do something in VR, but have you thought about putting something on the body of the goalkeeper, or using some of the equipment that already exists? So if they're already wearing gloves and, for example, the type of uniform, can you actually put something in that gear to sort of help them develop that technique of movement?
So far, I haven't thought about that, because so this machine is kind of a requirement we have to build. And therefore, I firstly like focused on the thing that's dealing around the machine, and obviously afterwards I thought, okay, we could do other things. But you're right, I mean, we already built a virtual reality version because the machine is not there yet, and we have to do something, right? So of course, yeah, that's an idea I could think about. Yeah, thanks.
I've actually have played handball for 5 years as a goalkeeper, and I think this machine is, it's not ideal because the only thing that you can train it with is reflex, because as you said, when someone step for their first step, you actually know where they're going to throw the ball, but sometimes you need this reflex, because sometimes something unexpected happens. For example, someone changed their head positioning, or they throw force. So I think it can actually help, but only in particular situations.
So, and like, I mean, couldn't you imagine, because the machine could like throw a ball in that corner and that corner in a faster time than a human could do, right? Don't you think that this could also help with coordination, for example?
Yeah, I think yes, but I think the most important thing is reaction time, because when machine throw the ball faster, if you don't have good enough reaction time, you don't have time to make good coordination of your body and to catch the ball.
Okay,
that's my idea.
Yeah, I actually have I have a very important person in my life that used to play handball almost whole his life until he got an injury. And yeah, we were discussing, he would be really interested in what you are doing, because we were discussing these ideas connected to research and how to improve goalkeepers. He was a goalkeeper too. And we were also talking about this aspect that Jakub was saying, because he was saying that you know, when other players are throwing a ball at him, he doesn't know in the moment when they are throwing, because they are also like trained not to be obvious and to somehow act. You know, I guess he would disagree with this, that he would know when the ball will be thrown at the moment of the first step, or at the moment of throwing the ball. Yeah, I think like he was also talking about this reflex, and that it's all happening in the moment when the ball is being thrown at you, not in the moment of the action. But yeah, I mean, we were kind of talking more about some kind of system that could maybe help goalkeepers be better in terms of like a self-improvement, like for example, having some kind of statistics based on the net. So for example, where are the weak spots? When do you mostly miss the ball? Like which angles you should focus more. But yeah, that's what we were discussing.
That's cool. Yeah. If you like to, we can talk later about this a bit more.
Sure.
I agree, because it's very common that trainers analyze goalkeeper play style, and they know their weak spots, so they can tell about the weak spots of the team, and it's quite obvious that the team would try to find and throw the ball in the weak spots of the goalkeeper.
I just have two references or pointers that might be useful. Maybe you've known them already, and just let me know. The first one is, I do know that what you described, like that, you know, like the goalkeeper already knows where the ball is going before the ball leaves the hand. I know there's a lot of work in baseball on that topic. So if you run out of resources in handball, there might be more in baseball. It's number one. And for your slackline, Rich Byrne, a former PhD student of mine, did this really cool game called Balance Ninja. So if you just use Google Balance Ninja, that use
I know that one.
Simulation. You know the one. Okay, yeah.
Yeah, that's amazing.
Success with that. So that might be a nice technology to explore with, maybe.
Yeah. Thanks.
Thanks a lot, Dennis.
Yeah, adding to what Floyd said actually about the Balance Ninja. Yeah, I was actually gonna. Isn't there somebody else who does galvanic stimulation, vestibular stimulation in the chat here somewhere? Yeah. Okay. I thought there was another person here.
Yeah, I think it's Mishinari mentioned something like this. No?
Well, actually, I do have knowledge slightly about GVS, but I don't directly work on GVS right now.
Okay. Do you think something like GVS could be used to train balance? Yeah, like in the example that he gave on like balancing a tightrope and like your muscles not yet knowing how to keep yourself up in an unstable surface or something like that. Do you think that would be like the getting good at like trying to counter the effects of GVS? Do you think it'd be translatable to something like that?
Well, quite a difficult question. Well, also, have you guys ever experienced GVS, right? Balance Ninja, right? Yeah. Maybe. Yeah. So I'm not sure if it will be really good for like handball goalkeepers or training, but it can be something like a trigger to like help which way to dive or which way to like, you know, react.
I was thinking more along the lines of the other example that he gave. So not handball, but the balancing on the rope thing.
Mm-hmm.
Would it be in that sort of training situation?
Well, hopefully, but I'm not sure about the method of how to, you know, get the, you know, the correct way to stimulate the person on the, you know, the feedback part. I think that's going to be an issue, but I do think that, yeah, the technique of GVS could be helpful, yes.
I could imagine that there might be the problem that you would stimulate only the outer muscles, kind of, and because you have so many muscles in your leg, for example, or in the knee area, if we would say this is the important area, that you can't like focus on just these specific ones you would need. So if you stimulate it, it's probably that you just stimulate the whole leg and then.
Oh, I don't mean stimulating the leg itself. I mean like stimulating like the vestibular
Okay, so that way,
create
yeah.
like a simulated sense of unbalance or something like that, and then trying to fight that, and then maybe getting good at balancing as a result of that or something like that. I'm not sure though, because like because when you're balancing on a rope, there's a lot of very small corrections that your leg makes to try to keep you up. Whereas when you do have GVS, I can imagine it would be like a more sort of like whole body trying to balance experience, because it's very like right in the middle of your head kind of thing, rather than your legs specifically. So I'm not sure how well that would translate, but yeah, maybe it might be worth looking at.
But maybe you don't have to fight it. You just let go, and then it helps you tune to the balance.
An automatic system, that would be actually really cool.
You know, I thought of something kind of funny, kind of related to that with the goalkeeper thing. I was just thinking, what information could we ever use to decode where they might be shooting in the goal? And, you know, I guess it would be the opponent's team who would be shooting into the goalie's goal. So there wouldn't be any method of communication between the two players. So you could use something like video to try to predict where they were going to shoot, but that would have a lot of latency. So if you had something like a sensor in the ground and you recorded their foot pattern, I think a deep learning algorithm could probably end up being able to get a few classifiers that told you a little bit of information about where they ended up shooting. I mean, we know there's a lot of hidden information there that we probably can't even pick up internally. And so, yeah, we could skip the deep learning algorithm or do that as a comparison and instead map that foot pattern or the kind of rhythmic information from the opponent's feet onto the goalie in the form of haptics or something like that, and see if they can themselves develop some kind of intuition based on this haptic feedback about where they're going to shoot in the goal. That would be kind of interesting.
Definitely, yeah.
You could even compare their developed intuition with a machine learning classifier to see if they come up with the same kind of things. And it would only take a sensor in the ground, just one or two actuators on the body of the goalie, and a deep learning algorithm.
Cool, thanks. So I think we should continue now with the next talk, because I don't want to take off all your time.
I think that's wise. Should we go with Stephen Villa? I think David? Hi. Do you want to present your...
Yeah. So,
thank you.
Share my screen.
You already, Rakesh, you know who's going to be next, so that person can prepare? Maybe announce it now.
Sorry. The next person after David will be Abby. So if they want to prepare. Also, I think we're going a little overboard because it's already...
Okay. Can you see my screen?
Yeah.
Yes.
Okay, this is kind of an exploratory thing. I'm still building the study. This is something that I want to try, but it's just in the first stage. So I want to support dance learning. I don't know if in your cultures happen the same, but at least in Latin America, we are so committed to dance. Like from our childhood, we are dancing all the time, and that's something that impacts on the social relation. But also, dance has an impact in the neurological functioning, as some evidence show. And yeah, and that I think that's why there are some works around that address this thing of dancing in terms of learning, but also in games, as Dance Revolution. I think that's quite popular and most of you know it. And also there are some approaches in virtual reality to address this thing of learning, and even a haptic approach using a robot to teach how to dance. But I would like to explore if there is any possibility of improving also this acquisition of skills by using wearable devices, because in several ways this is easier to use for a general public because it's cheaper and is wearable, so you don't need a robot or a setup that is hard to carry. So based on previous studies that we were carrying on here, I was thinking on using different clothes and different haptic enabled clothes and some commercial devices as field space to provide directional information around the hips and in the chest, and also hands and legs, to tell the user where to move next, not to rely only on visual information as the virtual reality and, for instance, people that is learning how to dance with YouTube should do, but also having this haptic feedback. The encoding I was thinking to use in this approach is something that is used basically in automated driving, that is time to collision, and it is a haptic encoding that needs information about the target, how far is the target and the direction of the target. So integrating this encoding in every extremity, in every part of the body, we could provide information about the steps, but also with haptic feedback, we could provide a kind of metronome to help people to keep the rhythm. And yeah, so some questions that came up when I was thinking on this is, does this the embodied feedback in the extremity lead to faster motor adaptation? Like, does it actually help to improve and to acquire those skills? Oh, sorry. And is it possible to generate motor representation using only vibrotactile stimuli and not providing visual feedback? How intuitive is this system, and if it is possible to actually rely only on haptics to learn how to dance? And how is the performance of the participant after the training with our system? Does the skill transfer actually works? Does the participant actually learns, or he will rely on the haptic stimuli? So that's basically it, and I would like to hear from you. What recommendations do you have? What are your thoughts about it?
Thanks so much, David. So we have about 2.5 minutes for questions, thoughts. So just letting you know, and if anybody has any questions for David.
David, I have some really quick feedback. You tap into something really beautiful, and I think you have an opportunity here to move from a dance interaction system to being quite specific and looking at a paired dance interaction system and being very strategic about where you place those sensors. So one of the things we know, women, different to men, one is leading, one is following in dance. Women are, we could do everything with our eyes shut. So the movement signals that we are receiving are coming from particular hand placements on the body. So we don't need an actuator on our feet. The cue that we might be receiving might be from our hips, might be from our shoulder, or from our hand, a pressure point on our hand. And that's telling us where our feet go. That's telling us where our head is turning. So I think you need to use the nuance of the dance that you know so well and be very smart about where you place those sensors on both the male body and the female body. And then you've got a really cool system.
Yeah, that's exactly a use case I was thinking about, because I dance tango, and yeah, of course the pressure in the hand is so relevant. So probably a vibratactile so probably a vibratactile stimuli shouldn't work as well, but shouldn't work so well, but probably the pressure feedback.
Yes.
And here comes the point of how necessary is the kinesthetic feedback, and if we can actually replace it.
Beautiful.
So yeah.
Beautiful. And then you can start to do translocated dance tests to understand how the partners are working geolocated somewhere else, and then bring them together. And I think it's great.
Abby, yes.
Yeah, very cool project. I always wanted to work on something related to dance. But I think one of the challenges you might face is how do you evaluate the effectiveness of such system in a way that we all know that learning takes place, especially, well, I do ballroom dancing and Latin a little bit as well. And I was in a club for 3-4 years, and I could see how people progress over time. But if you just organize several sessions with the participants, I don't know if you would be able to see whether the technology is actually helping or not. So I think in terms of evaluation, you might want to think about how to evaluate this, not just adaptation, but also the learning part. But very interesting.
Thank you. Yeah, that's something that I have to check, because yeah, it gets blurry where we can get actually the data. What are we really evaluating? What are we measuring? So yeah, that's something I have to focus on. Yeah. Thank you.
And I think another interesting thing you might want to try is if you could try different dance styles to train the participants, because by dancing with different people, as I know based on my own experience, you learn a lot. How do you adapt? So you could perhaps simulate the fact that you're dancing with different partners to further improve your skills.
Yeah, but I think that's something that is not totally clear, because as I show, I want to create this haptic, like this vibrotactile language to support dance learning, and probably is not the same analogy as the kinesthetic feedback that you have with a different partner, because based on the on the body of your partner, how strong is he moving, and so on, you have like a lot of information. But with the vibrotactile stimuli, you have less information. So that's the
I
tricky
see.
part.
Right.
Could you draw from Braille and how people use Braille, for example? Do you think?
That okay, I never talked about it, but it seems that will be a creation of a language more than a system to support directly dancing. So in with this system, what we target is to make it as intuitive and as similar to real dance as possible. But if we create kind of if we articulate a language, probably we can lose this yeah, this analogy of dancing.
So one of the things that you could consider measuring is qualitative data and body mapping. I don't know if you've heard body mapping from a somaesthetics perspective, and if like you could basically try and measure as to how aware they've become of their own body parts, after the session that you've set up for the participants.
Okay, what I have seen in some work is that they measure, at least in the virtual reality one, they track all the body, the topology of the body, and they have a virtual model that they have to follow, and they measure the accuracy of the participant to follow these movements. But it becomes different when we provide haptic stimuli.
Absolutely.
Probably I could measure how precise they reach the points that I want, because anyways I have to generate some virtual positions that I want the user to achieve. And yeah, probably the accuracy and the response time to get to those points will be a factor that we can measure.
Okay. And just one final point before we move on to Abby. Like, I don't know if you've played this game called Bounden on the mobile phone. It involves shared haptic feedback on the mobile phone. So basically, you and your partner can catch the same mobile phone and practice dance moves. And
No.
Yeah.
What's the name of the game?
It's called Bounden.
Uh-huh.
You should probably give it a try.
Yeah, I have to do that.
Awesome. Thanks so much, David.
Okay, thank you.
All right, Abby, take it away.
I'll just share my screen with you.
Who is on after Abby, Rakesh?
Okay.
Sorry, after Abby, we have Laya and then Alexandra.
Thank you.
Cool. Can you see my screen?
Yes.
Yeah.
Okay, perfect. All right, so I think I'm going to talk about more of an approach rather than the specific project. And I will also mention probably some of the unconventional problems related to movement learning that I like to tackle. So if you have any questions, feel free. Okay, let's go to the next slides. Yeah, so when I first saw the workshop, Augmenting Motor Memory, which sounds more of a cognitive approach to me, I thought, well, as I mentioned earlier, if we translate these into the project element that I was affiliated with, in our language, it's more facilitating motor learning using augmented feedback. And as I mentioned, there's many types of different feedback. There's visual, audio, haptic, or a combination of them. What we are particularly interested in, and also what I'm particularly interested in is called it's augmented auditory feedback, so movement sonification. And as I explained earlier, it's basically we transform the things that we don't usually get to hear, so the movement, into sound, and we create this conceptual bridge between the physical world and the digital world. So there are many different types of movement data. There's acceleration, velocity, rotation, position in a 3D space. And also there's a lot of sound parameters like pitch, tempo, volume, amplitude, and so on. So there has been no real established rules to say which one works better and where. Well, this notion is not new, so many studies have already demonstrated the capabilities, advantages, and challenges of sonification. So for example, here we have a sonified gesture for visually impaired people. And there has also been study on how the sonification of one's own footstep or one's own physical activity can change our perception of our body. There's also sonification games. For example, this one, I tried it myself last year at Glasgow. Team used the old PlayStation to encourage people to move in space. There's also rehabilitation. Here we have sonification to give patients real-time feedback on their movement, as well as shift their attention away from the pain. And of course, there are quite some examples of using movement sonification in performing arts. And this is the paper that I highly recommend for anyone who's interested in sensory motor learning from a more psychological perspective. So here they compared different types of feedback and also different mechanisms to provide the feedback throughout learning and which one works where. Yeah, so to summarize a bit what I learned, a little bit of mixture of the literature and also my own experience working on movement sonification, especially related to if we think about memory. I think sonic memory is definitely worth mentioning in a way that the idea of listening to sound can trigger memory has been around for a while. And sound has been presented as a resource for autobiographical remembering. So if you know the documentary Alive Inside, it shows how listening to music can enable those living with dementia to access memories. And there's also this intrinsic feedback, a relationship between sound and action, as we know from musicians. And my own experience, as I said, we conducted a learning experiment last year using sonification. And what we observed is that sound encourages movement exploration because you want to hear different things. And also stabilization. Once you learn the movement, sound actually works as a kind of regulation to keep you stay on track. Also, it helps shift attention. So the patients from rehabilitation studies mentioned that they feel less pain because they shift attention to sound rather than the movement itself. And also change perception of our environment, of our own body, because while there has been studies about how we perceive the size of the shapes related to the sound we hear at the same time, and also how when we hear our own heartbeat rate or footstep, it changes our perception of our body. So out of hundreds of interesting phenomena in movement learning, the following two particularly interest me. The first one is asymmetric capability, which is related to movement learning and coordination, as someone mentioned earlier. I don't remember exactly, sorry. This came out of the area hoop practice, where we can do the same figures, basically on the left or on the right. And the teacher always asks us to try both sides because, well, we don't want to develop a symmetric body, as shown here. But everyone managed to do one side way easier than the other. And the explanation given by the teacher is that we always have one side stronger than the other. But it's not just one side stronger than the other. It's about how we understand the movement and coordinate our body in mirror. And I don't know if this is something to do with being left-handed or right-handed. And I think the question is, how is this coordination represented in our brain, and how can we use different strategies to facilitate this coordination in the side that we're not very good at? The second question is something related to what Liz is interested in, and I saw Fred, our colleague there as well, is this breaking the old habits and relearn something we already learned in a different way. And this came up a lot in musicians and dancers who need to transition from a different music style or dance style and need to unlearn what they've already learned and to learn a new style. So here is sort of putting in the context of motor memory is a little bit related to how do we break memory and bring in new memory. And on top of these, I'm interested in how sound can help tackle our asymmetric capability and help us learn to owner. So if you have any comments or experience, I'd love to hear from you. Thank you.
Thanks,
I just thought I'd make a statement about your asymmetric capability, and you were saying something about like how that is represented in the brain as well. And I was gonna add that like I've actually come across that in brain-computer interfacing. So I don't know if anyone's familiar with the method of motor imagery in brain-computer interfacing, but essentially you can get somebody to picture a certain movement and have that translate to like a button command. So for example, think about moving your right hand or your left hand and then that translating to like a left button or a right button on a keyboard or something like that. And with that specifically for hands, I've found that if you're trying to train like a neural network to recognize either your left hand or your right hand, it's much more easier for the neural network to reliably recognize one hand over the other. So especially when I train it to my like brain activity, it always picks up my right hand, and like I can control my right hand very easily, but like my left hand, it's like very hard for the computer to pick it up. And I feel like, you know, there's a lot more like I feel like that translates to the brain, the handedness of my body, and then like that representation on my brain just being a lot more visible, just based on its like electrophysiology. And I was thinking like how could, like, it would be interesting to look at how you can sort of balance that out with sonification. Like that's something that I don't think anybody's considered yet. So that would be really cool. Yeah.
Thank you for the input.
Thanks, Nathan. Does anybody else have any other thoughts, questions, suggestions for Abby?
I had a comment when I was looking at the second image of relearning a skill, and you were mentioning maybe the role of sound in changing the pattern of movement. And I was thinking maybe also changing the place where that practice happens as well. I was thinking about that too. That could be something else to think about. So changing the environment, changing the object you are practicing the movement with, even if it's the same movement, to think about all other factors that might influence as well that pattern of movement.
Yeah, good point. Yeah, I think this topic first came up when I was talking with some musicians, because they, with a particular instrument, they learn the instrument in a very specific way, and then later on, if they need to change the way of playing, it's just almost impossible, because it's like typing. We've been trained, overtrained for many years, and if you give me a new keyboard, it would drive me crazy. And it's the same for them, and it's like you need to break the old habits and learn something different. And I don't even know if unlearn is even a process, or just you relearn something.
Yeah, I have an example of doing a weightlifting movement, which is a clean movement. So you're lifting bar all the way from the bottom, push it with your hips, and you catch it up here on your arms. So I was doing the movement wrong, and it was so difficult because the movement happened so quickly that I'm already used to doing it wrong. So one of the things the coach suggested was to actually break the movement in 3 parts. So try a different setup and only focus on this movement of lifting the top part. So just isolate the different movements, and then when you try to put them together again, that has an effect on changing that pattern.
Yeah, very interesting. I see hands.
Yeah, I just have one comment. It's about the user acceptability, and I'm just thinking that under different scenarios, might not always be practical to use like sound to communicate feedback. And I was wondering if you plan at any point to just maybe use multimodal feedback systems, like, I don't know, haptic and sound, so that it adapts to its situation you're in. And at the same time, I don't know, to be honest, I haven't read a lot about this topic, but it might like increase the user acceptability of having such a system. What do you think?
Yeah, I mean, it's a great point. So that paper from psychology, the comparing different types of feedback, is really great, because they also mentioned that mostly we use one type of feedback. And in fact, depending on the task complexity, so the complexity of the movement and your personal skill, do you have trainings in sports or in music or anything that related to improving how comfortable you are with your body? And so there are different individual factors that contribute to which feedback mechanism works better where. So in the end, they also proposed, in fact, that we should perhaps try this combination of different feedback modalities for movement learning. Yeah. Any other questions?
Would it be possible to share that paper that you just mentioned, like maybe in the chat or the Slack or something like that? I'd be
Sure.
interested in reading it.
I just texted her separately.
Okay.
Sure, I'll be happy to share that.
Awesome.
Yeah, I remember I was reading that paper quite a long time ago, and it took me so long to figure out the graphics that you just show on your presentations, you know, with what kind of feedback looks like this. Oh, it was so hard. Now I remembered.
Yeah, it's not the most straightforward figure to look at, but it does have a lot of information on, especially it's more of a summary of the studies in psychology and movement science. So there are a lot of studies related to, for example, ski training. Some of them also related to keeping your body balanced, and also swimming or anything related to human performance and movement learning. So it's really great, and I read it a couple of times also, and every time I learn new things.
Can I just ask one question, a little detail? When you talk about unlearning, which is interesting, do you actually mean disrupting the learning to enable the participant to be able to learn something anew, or are you hoping to erase the existing system beforehand? Does that make sense? Like one is additive and one is subtractive, if you like.
Right, I think it's more the first case, to not supplementary, but more of new way of doing things. Because I was talking with one of the musicians who told me that if you learn, for example, cello, you play the cello with you learn the cello in a way it's very personal, but then later on, if you want to try a different style, it's just very difficult for you to break the old habits, because the movement becomes so automatic and you just do it without thinking.
Sure.
And so I was more talking about how do we sort of break this automatic process, because that's sort of the end result of movement learning. It just becomes automatic. So we want to interrupt or disrupt this automatic process so that you could learn something different faster, or I don't know if it makes sense.
Yes and no, because I just think about really accomplished performers. So they have a body of knowledge, and therefore they can tweak their performance and take on new things because they have that foundation.
Right.
So, and their performance, you're right, is so fine-tuned that if they have to play with a different cello, they notice the difference more than, say, a novice cello player can adapt their performance one to the other, because it has been so finely tuned. So I'm not sure that they're really not adept at learning, but I understand your point of making it a cumulative learning, and how can you enable and assist that I think that's quite different, but a really important point.
Yeah, I think it probably exists more for those who need to train or try different styles. If you are trained as a classic player and now you need to do more contemporary, which actually requires very different skills. You're still playing the same instrument, but the way how you play is different. And I don't know, Lise, if you have something to add in terms of if you're trained as a classic ballet dancer, now you have to do contemporary or modern, and you really need to adapt yourself to different styles. So
not just skills, but passion as well.
Yeah, absolutely.
Yeah, I've been looking at, sorry, just to add in, looking at dancers who have had to switch to transition to other types of, who have taken whatever, transition to other styles of dance, but started with classical ballet, and whether that's injury or age or choice or whatever experience. And it really ends up being such a layered concept, because there's not only like, I mean, the way that you can look at habit breaking and through Alexander technique, I don't know if you know that, but also like the emotional impact and the approach, the fact that you're having different types of approaches. I mean, there's so much that goes into that, backing away in order to open your horizons process when you're approaching a new style. That's what I would say.
I have another reference. Again, if you know that already, great, because you mentioned sonification, but I know that there's also a bunch of people out there who try musification. So where they turn movement into not just sounds, like they sound like, ooh, 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 but rather, try to turn it into music so that you actually enjoy hearing the produced, like, not saying you don't enjoy the other sounds, but they are sounds versus people trying to turn it into music. You lose some of the richness of the or the details, but you enjoy the resulting auditory feedback more. Maybe that's a useful reference.
Yeah, absolutely. It's I don't think there's a huge discussion on how good the sound is, but it does affect our emotional status when we learn movement. And it's very interesting to see how people listen to sound or music in a very different way, because it could be very, very literal. Like you listen, if you are trained as a musician, you listen to more the change in the pitch or in like the sound texture itself. Whereas if you're not trained musically, a lot of times sound actually reminds you of something, so you make more this metaphorical association with sound. That's a very interesting point.
Yeah, anecdotally speaking, so I played guitar, and what happens a lot is depending on how you set your tone, especially on electric guitar, or what kind of wood material that you use for your guitar, the sounds are all different, and different movements are emphasized in different ways, given like what kind of guitar that you're using. As that sort of softly prohibits certain kind of play on specific guitar as a result. So I think I'm more talking about the quality of sound, but if they already have some sort of a mapping between what kind of music they want to play, what kind of sound they want, maybe you can use that as an intervention method to do something. I don't know how it's going to work out, but I think that could be really interesting. I also seen this interesting work. I reviewed the paper. It didn't get in, so I'm not sure if it's published anywhere. But they do sound dance performance as a collaboration between choreographers and programmers. So what they do is they compare different cases. So one case is the dance is pre-scripted based on what the dancers are going to do, and the sound is going to perfectly design for that. But throughout the performance, they switch it to random mapping between their movement and sound, and see how like new disruptive behaviors develop. And they discuss a lot of interesting observations, like because these dancers realize that certain kind of movement creates this really like wacky sound, they tend to do that more. So is there a way to sort of nudge people to go to a certain kind of movement? I think that can be similar to the guitar piece. Can be one method of utilize sound easily.
So is it a challenge of inspiration more than anything? Yeah.
And also if you move away from the notion of converting movement to sound, I mean, this is referring back to my own work on breathing, where participants, when they're doing slow breathing, because they had the like a breathing sensor attached to their mouth and earphones plugged to their head or ears, sorry, focusing inward on their own slow movement of breathing enhance their own personal breathing sound. So basically, it's not converting movement to any other sound, but converting focus of movement into amplifying their own natural sound. You know? Yeah.
Cool.
Awesome. Thanks, Abby. And if we can move on to Laya right now. Thanks again.
Hi, let me try to share this first. Do you see it? Hi.
No.
Do you see the slides?
No, not yet.
Not yet.
Not yet, eh? I don't understand why, because I'm actually, wait a second. I am missing the button here. Sorry, just a second.
Were you able to find it?
I am finding it, but I see now that I have to give permissions to it. So I just need one second.
Yeah, that's fine. You might have to do it if you're on Mac.
If we are, yeah, the thing is, I just recently installed it to Catalina, so I have to give permissions to everything again.
Yeah.
If we are running low on time, maybe we can change and I can figure it out in the meanwhile.
Yeah,
somebody else.
If Alexandra, if you're ready, you can.
Yeah, I'm sorry for that.
No, that's okay. You can settle down your permissions.
Yeah.
Yes, I'm ready. Okay. I guess you should be able to see my screen right now.
Yes.
Okay, so wasn't exactly sure in what form the presentation should be, but so it was an introductory slide. But yeah, the two things that you don't know yet about me is my current project. So one of my current project right now, I'm trying to automate the process of assessing the similarity of idea in order to enhance the creative flow in humans. And the second thing that I'm focusing on right now is designing a reward system and feedback for ataxia patients and their caregivers. They are currently using the tool, which is supposed to assess their motor performance, and in order to keep them motivated to use this tool, I'm trying to come up with some solutions. So this is the things I'm have in my mind right now. If some of you would be interested, I'm happy to talk about it later. But in January, when there was the time for submitting like my ideas like for this workshop, how should I contribute, I was like in totally different place. I was my presentation is gonna be more about exploring the idea and how we could contribute in this field of motor memory and human-computer interaction. So yeah, I was really excited when I saw this workshop because I wanted to, I saw it useful for my idea, for my research back then, and I hope I will go back to my ideas from January in the future. So I'm really excited to be in this workshop right now. So what I have been wondering is a little bit different. I was thinking how could we use the muscle memory in such a way to not only learn like a physical skill, not like learn how to dance or how to be a better goalkeeper, but I was thinking how we could use motor memory to learn maybe some more, I don't know, academic skill or something for school. And I was doing also a lot of reading about spatial memory, and this is what I would like to talk with you for a little while. Oh, sorry. Okay, so I was trying. We had this project idea in our minds back in January, me and my collaborators. We were thinking about coming up with a system that could learn, that could help learn to learn American Sign Language. I know it's not like an academic skill as I used to say. I had some conversations with my colleagues and experts about the American Sign Language, whether it could be considered as learning in terms of like, so it's not just a memorization, but it's also a learning process. So after a talk, we decided that learning a language, American Sign Language, would be considered a learning process, not necessarily just learning gestures. For sure it's connected, and it involves our movements and our muscles. So we were thinking about the system for the beginners starting to learn the American Sign Language, and how it could be enhanced with the use of this spatial memory, motor memory, died due to the fact that there was too many going on in the research of just recognizing the American Sign Language. It is like still the ongoing process of research, really broad, and they are still trying to come up with something that will have high enough accuracy to be considered good enough. But I was really interested in the process of exploring this topic about the spatial memory, and these are the sentences that I wanted to share with you. So, in brief, spatial memory helps to organize and recall a large amount of information, because people are using it. They are placing the items where they want in different locations in their minds too, or not necessarily. Also, like in the physical world too, there was this system, physical loci, I don't know, and yeah, like right now the spatial memory and all of the literature that is available is mostly focused on learning the commands, like on our computers, like menu commands, and people are coming up with different ways to be able to use the menus faster, like for example positional and directional menus. And here was a really nice example that the experiment was all about. Experiment from this paper. So the people were just placing 48 so-called comments, but they were just random words here in a room. so it was 48 words, and they were like really good at remembering them after mapping each word with an object in space. So and during like the second session, they had really significantly better. They were significantly faster and could remember more comments. And yeah, the final words that I want to share with you is some kind of inspiration for me, in terms of to continue this research and trying to combine these fields. It's what Barbara Twersky said, that spatial mental models do much more than just capture physical settings. They are replete with meaning. And also the second thing, mind creates spatial frameworks to keep track of where things are related to each other. Those spatial frameworks are essentially networks and can be used to keep track of relationships among any set of ideas. So not necessarily just places in real spaces. So some questions I've been thinking about, but they are like still open questions to me. Maybe you have some ideas how to answer them. Would be like how to enhance the spatial ability in humans, and whether the designers of games and UI UX designers could use this kind of spatial models and how to trigger them. Like for example, in our project with American Sign Language, we were trying to switch what is already suggested, what is already strongly suggested to work for the menus, to switch it in such a way to use these representations, these directional or positional representations, and our muscles. For example, we could use our gestures in order to select the proper place in a menu, and to memorize and to learn. So that's what were my previous goals, and I hope to come back to them in the future. Thanks.
I just say I appreciate the amount of like Barbara Tversky quotes that you got there. If you look at the first like paragraph for the paper that we submitted for this workshop, every reference is just a Barbara Tversky reference. So yeah, very relevant to like what I imagined like this workshop would be. We just thought I'd add that in.
Yeah, I mean, like she's like, I really like her way of explaining how humans think. This is something great.
We actually asked her to join the conference, the workshop, and she was interested, but she said that she'd already like made too many obligations around this time of the year, and she'd used all her travel funding. But it was nice to have a reply from her.
Wow. Now it's too bad. Yeah.
Awesome. So one of the things that I was relating your second question to, in regards to, you know, how do games do it? Like how do games enhance the spatial memory of its players? I think onboarding is one of the techniques that I can relate to quite well, because for example, if you consider the games such as Sims, or you know, the recently being played game crazily, which is Fortnite. Like every time you start Fortnite, you do the same exact thing every time. Like you jump off a plane, you glide, and you know exactly where you want to go. And I think that is due to the onboarding mechanic that has been used quite well in these games that enhances the spatial memory of these players.
Could you repeat the last sentence, please?
So the onboarding mechanic, which has been used quite well in games such as Fortnite and Sims, is the reason why players seem to know where they exactly want to go to in the game.
Yeah, that's interesting. So these are onboarding mechanisms? Or
Yeah, so like the onboarding mechanic.
Okay, thanks.
Yeah.
I just sent a paper in the chat for everyone. I think if you don't know it yet, it might be interesting to look at. So it's basically a follow-up of the Lossi paper. Nobody knows how to pronounce the name. And I actually did the experiment because it's from my previous lab. So it's also command selection in a virtual reality environment on the body. And I vividly remember that, so it's made up hierarchical structures like animals and eagles, turtles, and somewhere, and the commands are placed in your body. And I think how I remembered things, because obviously you could hard remember everything, but how I remember things is more like I made associations. For example, eagles are up high, and turtles, or no, actually penguins are on my left leg. I have no idea why. And so you somehow make this association between the position or the spatial information of the command and how you would interpret it. And I think that's very common among the participants, if I remember correctly from that paper.
Yeah, I mean, I also read that paper. It's so cool that
cool.
you have done the experiment. So yeah, I remember I liked it, and we were trying to refer to that too in terms of like designing these representations for like American Sign Language. At first, it was just the characters from the alphabet, so not really the whole words, because there's like so much going on, like recognizing your eyebrows or the position of your chest. So it was, we were just thinking about the alphabet at the beginning, and the representations were supposed to catch that aspect too. Like, for example, when you have a thumb finger, like on your index finger, it was more to the right, and after, when your middle finger was like more like up to the bottom, and just based, it was really connected. It's in order to somehow let people make these associations easier too with these representations.
Right. Yeah.
Thank you so much, Alexandra. If anyone doesn't have any other comments, I'm waiting for La's email because she is still unable to share her screen.
I sent it to you, but I'm not sure if you received it.
I haven't received it yet, but in the meantime, we can start Missionari's presentation if he's still online.
Yeah, I'm here.
Yeah, beautiful, awesome.
Oh, wait a second.
And we go back to Laya.
Fantastic. I'm gonna try to solve it on my side, on my end as well in the meanwhile, but hopefully you will receive them.
Yeah, thank you.
Thanks.
Okay, wait a sec. I'm not really familiar to Zoom, so I think I was requested to restart Zoom to share my screen right now. So is there, I think it would be better if somebody else can go first. Is it possible?
Yes, I got Laya's email and I can share the screen.
Fantastic, sorry for that. Good. So let's see how how we make it work. I'm gonna try to tell you like when when to move slides.
Yeah.
So yeah, hello all again. As I said at the introduction, my name is Laya Turmo-Vidal. I'm a PhD candidate at Uppsala University in Sweden. And my presentation is also more focused on an approach, or the approach that I've been following in my PhD to support movement teaching and learning rather than one project. So I'm not gonna go very in detail to each project, but I'm happy to discuss them afterwards with all of you. So yeah, I've been trying to do in my PhD is exactly that, to support movement teaching and learning practices through interactive technology. And I've been focusing on supporting physical training practices that are co-located and that happen in real time. And the technology or design approach that I will be briefly talking about is using open-ended augmented feedback. So using technology that gives this open-ended augmented feedback, and also use this technology as a pedagogical resource in interaction. So I'm not using technology as a, how can I say, as the instructor itself, or as many projects do, like they try to make technology be the ones that are guiding this practice, or the ones that are giving only the feedback if it's right or wrong. But I'm trying to design this technology so it becomes kind of a resource that both instructors and trainees can use in their practice. And the type of technology that I've been designing is what we call technology training probes, or TTPs. And this is an array of wearable technology. If you go to the next one, please.
Yes.
Thank you. And I've been looking at 4 practices so far. One of them is yoga for, and the practice, all of them share these characteristics. They are instructed practices, they happen in a collocated setting, and there are social practices as well. And I've been looking at yoga for adults, especially for beginners and intermediates. I've been looking at the strength training. Some of these exercises are like weightlifting as well, for adults, beginners, intermediates, and advanced. At circles training, it's a course for children with mild motor challenges, and handstand training with professional artist performers. And we've been deploying our TTPs, our technology probes, across this array of practices. And the approach that I followed is a research through design approach. All my evaluations and most evaluations are qualitative, using video and interaction analysis with experts and interviews. Oh, next slide.
Yeah.
And this is just a selection of some of the technology training probes that I've been designing. What they are is, as you can see, very basic wearable prototypes. And what they do is what we call exteriorized proprioceptive information. It's a type of a sensory augmentation. So what they do is like they focus on one aspect of performance, like it can be tilt, or it can be, I don't know, alignment or movement trajectory. And they provide like this exteriorized feedback through visual, haptics, or sound. And the characteristic of them is that all these augmented feedback is open-ended. So we don't embed the representations with a meaning or with an assessing role, like this is right or this is wrong, but rather they are open-ended in meaning. Both instructors and trainees can create their own meanings based on this technology. And also important is that this feedback is both it's both for a first-person perspective and a third-person perspective, meaning that both trainees and instructor can access this feedback at all times. So if we go to the next slide. Yeah, this is an example, one of very basic examples of one of the probes, what we call from balance. And this is a belt that gathers the tilt in the frontal plane. And depending on how you move from one side or to the other, it gives different sorts of feedback. So it gives visual feedback. You can see, I don't know if you can see it here in the GIF, but you can see how the button of light moves across the lettering. It also gives, you cannot see it here, but it gives haptic feedback to the wearer by means of vibration motors. So depending to which side you are leaning, you will hear a stronger vibration to that side or the other. And it also gives a haptic, auditory feedback, like by means of beeps that increase in frequency the more misaligned you are. So that's one example. Yeah. And another one that I'm going to talk a bit more today is body lights, which is a kind of similar in terms of conception, but very different prototype. This is a 3D printed laser prototype. And what it does is like you can wear it in different parts of the body, or you can wear it even in equipment, and it projects into the environment. And by looking at the interplay, I will show it a bit more later, but by looking at the interplay between the feedback and spatial elements like markings on the wall or lines drawn on the wall, so it's quite able to visualize movement trajectory, pace, posture, and muscle engagement, like offer a visualization. Yeah. And just as an example, we tried, as I said, like we tried these probes across different practices, but now this guy, I would be presenting, if we were in Hawaii, a paper about body lights in strength training, where we were exploring the usefulness of these open-ended visualizations to support a very normative practice of strength training. And what we did was design the inclusion of this technology in 18 different exercises that you can see here. And to show you a bit how it would look like, if you look at number 1 to 5, more or less they follow the same principle. You're wearing body lights here on the chest, and it projects across. And you need to position the cross in a way that it's always, in these situations, always crossing your hands. So what we would do usually is like make the trainee put themselves in the proper position, and the personal trainer, because we did already study with the personal trainer, the personal trainer would help them position the cross in a way that is always like crossing the hands. And then at the point that you move away from the correct position, the cross would lift, like it would move closer or further from the hands. So it's a very visual way to see when you are in the correct position or when you deviate from that. So I did this study with, we studied with 15 participants, beginners, intermediate, and advanced, that they trained 3 times with a personal trainer. And if we go to the next one, some of the insights that we found is that it helped them a lot in executing movements. It increased the movement awareness. They really became aware of how is it that they were moving when they were doing things wrong as well. So it helped out with error identification, but also it helped a lot the communication between instructor and trainee. So it helped the personal trainer in this case explain very complex movements. It helped them find a benchmark for what is a correct performance. And also to adapt, the personal trainer could use this technology to, or this augmented feedback, to really adapt the feedback and the instructions to the individual trainee, to what is it that they needed. And in case that you are interested, I'm putting here like the link to the DL. And also if any of you is interested, the Nordic part of, I mean, some of the Nordic authors are running an online CAI event that you can see here as well. And I'm gonna be presenting this work on Tuesday, if any of you is interested. But anyhow, if we go to the next one, what I want to say as a closing up is that the approach that what I've been talking now about the body lights, we've seen more or less the same kind of benefits with all the different probes in all the different practices. So it has helped trainees across these very different practices and target groups to increase their body awareness, to help them in executing the movements, in correcting the movements as well. And it also has helped a lot in enhancing the communication between people with different expertises, right, like instructors and trainees. And from the technology approach perspective, what I've seen is that using this type of probes provides an external focus of reference and feedback, which is known quite a lot in sports science, that it helps people understand their movement and in improving. It creates a shared frame of reference by giving this first-person feedback and third-person feedback. It can create this shared frame of reference that people can use to discuss and to communicate. And also this concept of intimate correspondence, which has to do with if we make this mapping correctly, it doesn't work the same for all the probes, but for most of the probes, the trainees really feel like this technology is like an extension of their body, like the feedback that they get, they perceive as an extension of their body, and they can use it actively in the training. And from the other part, using this open-ended feedback that doesn't have like a defined meaning, we've seen that allows us to use this technology in a lot of exercises and practices that are very different among themselves, but also this concept of adaptability. So we've been able to use these technologies for different trainees, people with very different body capabilities and also very different skills. And the final one, I think. Yeah, thanks. So my question now is that, as I said in the first introduction, I'm taking an ethnomethodological, very situated perspective. And what I would be interested in studying in the future is how this affects the role of learning over time as well, right? Like now I know that in the moment training practices, it offers all this range of benefits, but from some studies like this with strength training, where they trained over 3 sessions, I could already see how their use of technology or this open-ended feedback changed. And for instance, one example was that in the third session, the more advanced trainees were saying, I don't need the technology anymore because I remember where the light were supposed to shine in these exercises. So I can draw from this previous experience and maybe I wouldn't need the technology anymore. So I think that one interesting thing regarding to the topic of this workshop for me would be to understand like what role, what changing role do these technologies play over time to support movement learning. And yeah, that's been it from my side. I'm happy to discuss more projects more in detail. And I'm sorry for the weird type of presentation, but I think it's worked more or less fine. I don't know if anybody has any question or any comment.
Can I just ask about the? Thanks so much. I really like the approach with the open-endedness and the third person perspective. I just wanted to know, did I see that right with the belt that you showed? So it had an LED light on it, but it looked like as if there were balloons around it. Do they blow up?
No, this is just because this design for this specific probe was designed initially for the circus training with kids with motor challenges. So it's just like a decoration to try to make it not so techy, prototypey, but just to put some lights. No, right now they are not interactive at all. It's just like a piece of cloth next to it. Unfortunately, because it could be nice.
Just with that mention of first and third person, and then Floyd talking, it reminded me Floyd has written a paper about like designing for the second person perspective, which is like really interesting. Like maybe that would be helpful as well for you to have a look at. I'll try to find the paper. I think Floyd might have it as well. But yeah, just another perspective to consider. I thought like it would be very interesting to think about in this context.
Yeah, fantastic. Thanks.
Awesome. Thanks, Laya. Unless anybody else does not have any other questions, we can move on to Michinari. All right, let's move on.
I get in the screen okay? I guess so. Okay. So what I'm going to talk about is it's a little bit vague. I'm not going to talk about a specific project, but I was always thinking about how to get used to artificial external forces for bodily movements and, such as the things like EMS. I mean, I've been like working on EMS and like during my research on EMS and muscle actuation, I was always thinking of the thing where you can get used to the stimulation, right? So if you have ever experienced EMS, you may know that it can sometimes be annoying or feel uncomfortable. So, but if you get used to it, these kind of negative elements gradually fades out. And one technique is to like help the stimulation. I think it's good, and things like that is really useful. And like when the EMS starts to try, like for example, bending your fingers, like you can help the signal for the actuation by slightly bending your finger by yourself as well. So I guess people who are used to EMS know this kind of things, and they act like this unconsciously. And like it's like kind of memorizing or tricking your muscular motor, and it can change how you perceive the electrical stimuli into like more positive ways. So I think like it's really kind of similar to ukemi. Ukemi is a Japanese term typically used in judo, like where one can perform artistic falls or rolls when receiving attacks. So it can be used as a technique which helps to reduce the impact or risks or injury. And yeah, I think that these kind of theory can be applied when like receiving these kind of stimuli, for example, EMS, and it can help to improve the experiences and to like avoid the negative aspects of these kind of techniques for motor movement. And not just for EMS, I think that it can also be applied for illusionary haptic feedback and haptic feedback, many other things. And, you know, for example, if in examples of illusionary haptic feedbacks, you know, actually the force is quite weak. So if you like try to adapt to the force and help the force to make you trick yourself, you can get a better experience. You can feel the force is larger and you can feel the experience much more better. So I think like these kinds of, you know, techniques for motor movements can be like, you know, kind of tricked by, you know, trick the memories. And I think, you know, these kinds of things like EMS, you can get used to it, you can get used to the stimuli and you can memorize how the stimuli feels. And, you know, when you get the stimuli, you get to understand how you should move. Then you can generally adapt to the force and make the experience and the learning effect possibly better. So that was what I was thinking of when I was working on EMS, and I'm not sure how much these kind of things have been studied. I don't think it has been studied in depth yet, but yeah, I would like to share this and discuss this, and I'm not sure about, yeah, I maybe help other people working on EMS. Yes, and that's it from me.
Thank you, Michinari. Does anybody have any questions for Michinari? Thoughts?
I have a question. Sorry, I go back to your very intro where you said you had several implants. Can you tell us
yes, yeah.
What are the implants?
Oh, yes. I have. It's really difficult to see it, but I have 3 in my left hand. I have 2 chips over here. One is a typical NFC chip and another is an LED. And I have a larger thing over here. Can you see this thing? Yes, this is an NFC as well. It's the antenna is a little bit larger, so it's much more easier to read.
What are you going to do with that?
Well,
like, was it an experiment, or is it like, did you try that as part of a research project, or?
Oh yes, I was interested in doing research on this thing. So, and I was trying and doing some experience on this, but so far it's not really doing very well. I do think working on magnet implants will be much more practical for HCI context.
Why? Wouldn't the LED be more HCI-ish than a magnet?
Well, actually, you know, there's many sensors embedded in iPhones, you know, smartphones and everything, but, you know, NFC is quite difficult to treat. I mean, it's quite small, so it's quite difficult to read, and there's little. I still have to explore the potentials of it, but so far it's quite. I'm struggling to find applications based on NFCs, but there should be more space for magnets, I think, at the moment. Yeah.
Thank you.
I had a comment not in relation to this presentation, but listening to a few of them already. And I hear a lot of things in relation to learning to move and learning the technique and all of these things. But I was wondering about all of this learning in relation to the actual person doing an improvisation. So is that improvisation the opposite end of using all this technology to learn the move, learn the technique, and then what do you think about the role of technology during improvisation, which is something that really comes from the knowledge that I have in relation to the situation? Yeah, so that's the comment.
Actually, I'm not familiar to the word.
No, that's I think that's an open question. That was not necessarily to what you presented. It made me think about when you showed the image of judo, the ukemi term, that the person can perform a movement just to fall graciously on the floor, not get injured. So it made me think about the improvisation of that movement based on the situation. So I think it's an open question that was not necessarily targeted to the presentation.
Okay. I'm currently struggling to understand their term. I'm sorry.
Wait, what was the word? Is ukemi?
Ukemi.
Yeah, it kind of reminds me of. I was gonna ask, like, do you have any ideas or examples of a context in which that might make sense? Because it kind of reminds me of like when me and my brother would play like sword fights or like have Nerf wars with each other and stuff as a kid, and you'd like get hit by a Nerf bullet, and like you'd over exaggerate like that impact to emulate like how real that shot was. It's like, oh, like, and it kind of it brings like a massive level of immersion in that context. And I can imagine like something like that might be useful in like VR or something like that, especially if you're playing like a multiplayer shooting game. You get shot, you get the EMS stimulation, and like there's a level of performance there. When you get hit, you kind of like act it out, maybe like brings a new level of immersion or something. Is that kind of like what you were thinking along the lines of? Or?
Oh, well, actually, not directly. Well, actually, that reminds me of an example of my previous work, which I used EMS on your eyes, and like I actually study on that and asked past participants to first blink by yourselves and react largely when you see a video being punched, and as a comparison. You use EMS to artificially make the person blinks. But what happens is when you act to like blink yourself, it didn't really it didn't perform really well. But when you use like the EMS, there's additional things like where people get frightened by the electricity, so that actually helps to like some kind of make that punch real, or make it some kind maybe feel pain or fear much more. And yes, so maybe that's yeah, that was the thing that I was doing and interested. But that was a case what reacting by yourself in an experiment fails.
I have like one to Mehmet and one question. So one to Mehmet and Nathan. There's already, I think, a couple of papers, like one by Lopez and one by Khamis, and both are tackling this kind of immersion VR. By Lopez, as far as I remember, it was about like getting the feeling of VR objects. Like if you are approaching an electrified wall, how would you react to it? Like you would get the feeling. And another one was like emotion activation by EMS. So if you are standing in a VR scene and there's kind of an explosion, then you'll get your arms like crazed and reacting to that. So this part I think has been like slightly explored, not like exclusively.
Oh, sorry. Keep going. Yeah.
No. I have a question to missionary, so you can just go.
Oh, I was just gonna say like that kind of made me think of and this together it made me think of, I saw this talk last year at Kai where it wasn't EMS, it was TDCS, and they had people in VR and they had their hands out, they had hand tracking and everything, and there was a ball rolling onto their hands, and without TDCS, there was like no sensation of like that ball when it hit their virtual hands. Like they couldn't feel anything, obviously. But when their brains were stimulated with TDCS, there was like an illusion of their balls, of that ball like hitting their hands, like once like the virtual ball made contact with their virtual hands, although there was no physical contact with their hands, because the neurons in the motor cortex were excited and kind of anticipating that contact. Like maybe you could do something, like maybe that's relevant. Like maybe you can use the stimulation to kind of like excite your muscle like nerves to anticipate a movement or something like that, and kind of create an illusion like that, maybe. I don't know.
Was it in Kai? Did you
Yeah,
see Kai?
so it was at Kai. It was Kai last year. It was one of Pedro Lopez's students, I think. It took me a while to find the paper after I watched the talk, but I'll try to find it again now, and I'll share it in the chat.
Maybe it was TMS, not TDCS. Magnetic force on the
I don't. It might be. No. It was TDCS. I remember they had like. Okay. I remember the sponges. They actually had like sponges on the head, like in the picture. Yeah. So no, TMS. I think like you could definitely get like a very notable reaction out of it. Although I think if you use TMS in that context, like you'd probably like have your hands move as well. Like you'd feel force. Whereas this one was just like it felt like there was touch. Like an illusion of touch. It wasn't really like a forceful stimuli. It was more just like a kind of like a just touch. It was bizarre.
Okay.
I think it was more from the anticipation and your brain creating that, like filling in that kind of like the incongruity between what you're seeing and what you're feeling, and your brain trying to fill that in, rather than like the TMS thing where it's just like stimulating a massive population of neurons by like depolarizing them.
No, it's like actually really good because it's sort of collaborating.
Yeah.
Like you have to have some element of being voluntary and moving. And,
like we both come from like a neuropsych background, and in that there's a lot of like talk about your brain being like a Bayesian prediction machine. You know, it's just constantly trying to predict what's going to happen next. And so if your neurons are excited to the point where it's predicting that you're going to feel something, and like maybe it is like it's creating that it's filling that gap, maybe.
Yeah.
But yeah, I'll try to find the paper. It was pretty cool.
I just have one question. Missionary, when you spoke about like not deceiving, tricking the brain to sense something with the EMS, are you talking about like perception manipulation? Because I had this idea that maybe I can use EMS to like train the people, or like make them learn that certain objects are heavier, not by the shape, but rather by manipulating both the shape and the size using EMS to communicate that. Do you think it's possible, or?
Well, actually, I know an example which tried to make things feel heavier by using EMS. And in the paper, well, actually, it was published in a Japanese journal, so I don't think it's international, but the results suggested good results. But previous to that, I actually tried a similar approach by myself, but it's actually quite difficult. I mean, the weights, the deformation of the skin is quite important for the weights to perceive things heavy. So, just stimulating the muscle.
But in a VR environment?
I'm sorry?
In a VR environment?
Oh, yes.
Okay.
So not just simulating muscles, but doing things on your fingers or to deform the skin will contribute much more to perceiving weight, I guess.
Okay, thank you.
All right. Thanks so much, Missionary.
Thank you.
All right, we have our final presentation coming up from Caitlin. Caitlin, take it from here.
Gotcha. I'll get that up right now. Okay, let me see. I shall share my screen now. Okay, I think you can see that. Can you hear me?
Yes.
Okay.
Yes.
Great. Anyway, this is just, let's see. Oh, it has transitions. Sorry, I didn't realize that. Anyway, this is just who I am. You know, I'm from Georgia Tech and at Stanford right now. I'm actually a fellow with the National Institutes of Health in rehabilitation. So specifically, I am studying muscles and sensorimotor rehabilitation right now. So that's just a little aside. Prepare for the transitions. I wanted to call to your attention just a method of motor training that I studied before, which I think you all might find interesting. Essentially, what I used was a wearable computing device to apply specifically designed haptic cues, which were designed to train discrete motor tasks. Floyd mentioned this. For instance, typing, playing piano, discrete motor tasks which can be easily translated into haptic cues. By using a wearable computing device, we can apply these haptic cues again and again for lots of repetition, which we know is great for learning. And we can also apply these cues when people aren't even actively focusing on training this motor skill. So they can kind of have some training of their body parts in the background. Because these haptic cues apply to the body parts, they're essentially trying to activate the same areas which you're going to move, kind of trying to make an intuitive haptic mapping for this discrete motor skill. It sounds complicated, but it's really very simple. It's the repetition of tactile cues to the body parts to train them for a motor skill. But what's interesting are some elements of that, and then some questions which came from that, which I'm interested in exploring in the future, or which I found most salient from this research. It's first the note that haptics as a modality is really good for motor skill training because it applies directly to the body, which may be more intuitive than, say, reading from a piece of paper. Although, of course, it should be noted that humans can learn very well by watching people do things. So visual imitation learning is also very strong. Also, I think it's interesting to note that haptics, specifically vibrotactile stimulation, creates the same, in part, afferent or sensory feedback as normal movement does. So for instance, when you move your arm, you get kind of proprioceptive feedback from the muscle afferent sensory receptors. Vibrotactile feedback produces the same, in part, feedback as normal movement. So without even moving your arm, we can apply essentially artificial movement or enhanced sensation of movement. Something interesting to think about. Then some interesting questions which emerged from this work. I mentioned how this can be training while you're not paying so much active attention to learning the motor skill. And it's been found that attention can interfere with motor skill performance. We know in the simplest way, when somebody watches you walk or watches you type, you can suddenly become overconscious of the motor actions and not be able to do it. For instance, I myself, maybe you've experienced this, you're riding a bicycle and you know you're going to go over a difficult path, you can kind of tense up and then suddenly you crash because you're not able to release kind of the automatic function of the motor skill. So relatedly, if we can use computing devices to help train the body parts while you're not paying so much active and potentially restrictive attention on training, could this potentially be beneficial? So this is about the role of attention and how it might actually inhibit motor skill training. Secondarily, of course, how can we use, for instance, haptic systems for baseline learning, which is kind of how to do a skill, versus practice, which is kind of just going through the motions again and again until you're more fluent with it. And finally, this is exactly what Floyd mentioned. In my work, I noticed that through different applications of this haptic training method, we could train these motor tests, but there was also some evidence that we were able to train discrete information, and even what Sarah had mentioned at one point, which is perceptual skills, or in a high or low intensity situation, simply recognizing data. Perceptual skills is the ability to more quickly recognize patterns and things like that. It can be visual, can be tactile. But focusing on the declarative skills, I trained declarative information to be associated with haptic cues. For instance, you press several buttons and that's associated with a letter. You learn that for all the letters, and it's a very complex mapping. For instance, how to type on a very complicated keyboard. And what I found was that people could then extract the declarative information, i.e. which keys equated to which letter, from their motor training. They were simply trained on the haptics. It's kind of a mapping to their body, but they could use their body to tangibly remember this declarative information. So this is exactly what Floyd was mentioning. This is about the interplay between using a motor training to help you learn declarative information, or maybe he's investigating vice versa and such related topics. But this was one of the things I distinctly noticed. Now, there's a few things to be noted with that. For instance, the participants did want to use their bodies to help recall that information which had been trained to them physically. So they used a physical representation to recall that declarative information. But I do believe one of the things of note from this research was that motor skill training can help you learn other content, such as declarative information. And I believe that's what Floyd's interested in. So it just happens to be on my presentation today as one of the most salient questions I think is worth investigating here. Now, simply, right now, I'm working on wearable computing devices that provide stimulation, and that stimulation can help you recover from central nervous system injury, essentially. It's just that your peripheral nervous system pathways are intact. You provide electronic stimulation, specifically haptic stimulation, to the body parts. It transmits through the peripheral nervous system. And when you have a central nervous system injury, such as a stroke or spinal cord injury, the damage is really to the central processing, which is the brain, for instance. And the brain can change a bit in response to peripheral stimulation. I'm also working on designing accessible devices for those who have motor disability. So that's another consideration. And some things that I'm interested in with all of you are hearing, of course, what you're doing. What modalities are you working in? Imagining new training scenarios where you might use similar methods, such as the haptic training method. And of course, imagining therapeutic applications, which I mean, one less clinical, but still therapeutic application is the idea that those who have learning disability could use a more tangible method of learning to, say, learn language if they have dyslexia or something like that. anyway, those are my interests, and that pretty much sums it up, I think. Yeah.
Really cool talk. Really enjoyed. There was a lot of elements that I thought were awesome in that. And like just towards the ending when you were saying the stimulation of the peripheral nervous system, you know, the brain still has connection with the peripheral nervous system, and then you were talking, so you were talking about peripheral nervous system injuries, and then like being rehabilitated to gain control of those limbs again, or so that's what it sounded like. And then when you went to like central nervous system like injuries, and then you're using peripheral nervous system stimulation to like therapeutically like rehabilitate the central nervous system. I thought you were going to say like stimulate the central nervous system, and then you kind of went to talking about stimulating the peripheral nervous system again, which is like which I didn't think of, like which I wouldn't have originally conceived. And then when you're asking like, what do you guys think? So I do research in brain-computer interfacing, specifically brain-to-brain interfacing, and I've been trying to come up with a way to transmit like signals to people's brains. So I've been I've been doing a lot of reading on TDCS, and one thing that I found on TDCS is like a lot of literature centers around neurorehabilitation for things like stroke rehabilitation and stuff like that. And there's a lot of stuff on like motor rehabilitation after stroke injuries, so, like those kinds of related things. And there's a lot of promising results on that. And I was wondering, like, have you looked into TDCS at all or anything like that?
Yes, definitely. Hold on, let me just clarify something. Not sure if I heard you right, but I just want to make sure you know that I'm not using peripheral stimulation to address peripheral nerve injuries. I just simply believe that peripheral nerve injuries won't benefit from peripheral stimulation, particularly because the pathway will be cut off. Although, of course, if it's to a very low degree, such as a surface injury, electrical stimulation can facilitate recovery there. But just like you stated correctly, I'm using peripheral stimulation to help recover the central injury.
Gotcha, yeah.
And what you were asking about is using kind of more central stimulation to recover the central injury.
Yes.
And yes, I'm aware of that. That is a fine field. They're doing a lot of that. They're doing also transcranial direct stimulation and things like that. Personally, I work in peripheral. It's a little less invasive and maybe even a little more intuitive, because we have those pathways still intact when you have a central nervous system injury. If you think about it, our peripheral nerves are still in good condition. So we can utilize those pathways in the same way we utilize the direct application of stimulation to the brain. I think that hardware for direct stimulation of the brain is a little bit cumbersome right now, whereas I'm trying to move away from things like electrical stimulation and use simply tactile stimulation, which may even work more directly with muscles, which have reflex circuits through the spinal cord and may not even need to fully reach the brain per se. So it can help with some electrophysiology regulation just in the muscles. For instance, you can have involuntary muscle contractions after some central nervous system injury, and working directly with the muscles can help provide the right modality of input that can help re-regulate that muscle activity. Anyway, I think the body of work is really good, but I think peripheral stimulation might be a little bit more suitable for lightweight mobile devices that could be more convenient and friendly to the user.
Yeah, I agree, especially like what I've experienced with TDCS at the moment. It is, would you say that like a problem with it might be the resolution of the central nervous system simulation? Because one thing that I've experienced is that you don't really have that finer resolution of at least with haptic stimulation, you could probably target like a specific muscle group or something. Whereas if you're doing TDCS, it's pretty much your entire motor cortex when you're stimulating. Although I've been seeing some like promising results from like there's an emerging body of work moving away from TDCS and using like ultrasonic stimulation, I think, or yeah, ultrasound, which you can stimulate the central, like the brain, at a spatial resolution of about like the size of a grain of rice, which I think would be very exciting to see where that goes in terms of central nervous system rehabilitation.
Definitely, and I think those techniques are looking at trying to increase plastic recovery of the lesion areas and such. Essentially, even trying to increase. I mean, sometimes they use stem cells implanted, and they try to use electrical current to increase the proliferation of the stem cells and things they put out in the brain, as well as I think just try to work with the original tissue to keep it from dying essentially too much. But if you think about it, that's definitely treating the lesion, and that's great. But if you're trying to recover limb function, for instance, it's not exactly directly working with the limb, is it? Whereas, for instance, using something that uses the peripheral nerve pathways with the limb might help the brain kind of relearn how to use the limb a little bit more, right? So I think it's kind of like the central stimulation is kind of trying to increase the overall health of the brain, but it's not exactly targeting the direct pathways that might help return such things as movement.
Yeah, I see what you're
so you
saying.
might, yeah, something to think about.
Yeah, I wanted to, yeah, go ahead.
Gone.
I wanted to ask you, I mean, I really like this question you mentioned about learning without interfering too much, like to learn and not having some kind of like distractions. Am I understand correctly? Like that you are using this vibrotactile feedback in order maybe to try to achieve that. So, so what about this this haptic feedback in form of an ultrasound? Yeah, that's because it seems like less like it seems more natural to me. Maybe if you have like this feeling based on the ultrasound, like there was like this ultra haptics, like I think they are called ultralip now, that they've provided like this interface that you can control from mid-air, and it gives you the feeling like in the air. So this is something I'm like a really big fan of, and I could imagine that having such ultrasound feedback and not having some kind of vibrotactile device could be like more maybe natural and less disturbing. I don't know. Maybe like more unconscious could help.
Sure,
Do you
definitely.
see potential to that?
I think the first point of concern when you're trying to train a skill using tactile cues applied to the body is how to map the skill in the most simple and intuitive way. So if that can provide a modality to map, for instance, more continuous skills, such as, a continuous movement rather than a discrete movement, that'd be great. And I think the only concern might be if that apparatus isn't very mobile, because the power in this technique is the ability to apply the cues again and again and again, perhaps in the background of while you're focused on other things. And that's why having a wearable form factor enables those things. If that ultrasonic isn't too mobile, it might be a little bit stationary for the participant, and thus interfere with the repetitions and the truly kind of in the background nature of the training method, but definitely a possibility.
Okay, thank you.
Floyd, did you have something?
Yes, I just wanted to ask if you can give us more of those examples of yours where you said people showed signs of being able to recall declarative
Yes.
declarative facts that are facts
I
or
can give,
declarative recalls. Like what do you have? What did people do?
yes, I can give you a couple specifics.
Yes, please.
Just off the top of my head, and I wrote about this in my thesis, so it's all written out there for future reference. But for instance, we trained people Morse code. That's simple one-channel temporal sequences essentially, but it means dots and dashes. So basically, kind of a long stimulus, usually auditory stimulus, typically. Long stimulus is a dash and short stimulus is a dot. We use tactile, so that's like long stimulus is a dash, short stimulus is a dot. Each letter is a collection of those, which makes like a little pattern. So it'll be like tap, 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 tap. That means A or something like that. And so we train people just on that, just associating, you know, audio cues with a little pattern. That's how we train them. Lots of repetition. Then they learned it while they were paying attention to a video game, basically. But so basically we use this tactile cues and audio cues to train them. And then, you know, then we gave them like a quiz throughout the study, which lasted several sessions. And it said like, okay, what is A? Write it down. And then they had to go, okay, A is like do, 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 do. That is like, that must be like dot, dash, dot. Like, then they figured it out. They extrapolated that. Also, it was kind of like a recognition quiz where it was like, show them dot, dot, dash, dash. And they had to be like, that's, I can figure out that is tap, 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 tap. That's G. Obviously, I can remember that. So that's one aspect of where they were able to extract the declarative information of both what the letters were and even kind of come up with this dots and dash thing just from the tactile feeling and the explanation behind the concept. And then also when learning how to type Braille, I taught people how to type Braille. Braille is, you know, the tactile dots that you read with your finger, but like our language is typed using a keyboard, of course, but their keyboard is nice and stationary. It only has one row, but that means to produce each letter, you have to press down lots of buttons at a time, which makes it very complicated. So like for G, you know, 4 fingers, for like F, you know, different 4 fingers, it's a complicated system. We did the same kind of training method, stimulate their fingers in a haptic pattern, associate with the letter. They learned how to type the Braille really well. Then we also, we gave them visual and tactile quizzes where we said, what is this letter? And actually, I mean, they made a really big leap. We just gave them a key that said, the keyboard corresponds to the dots of Braille in a linear fashion. So it got like 6 keys here, got 6 dots here. It's a correspondence. So they learned physically on their hands, and then we gave them some, just that key that just showed how it corresponded. And then we gave them quizzes where it showed the dots, and they had to come up with, oh, that is G, that is F, and they had to write it down. They also did that with their fingers, which is basically the same thing. They just feel it with their fingers and they write it down. Then they translate it from what they felt on their hands. And then also kind of a reverse quiz where we said, all right, write down what dots are for Q or whatever. And they had to go, Q. Q is this, so Q is this, and they translate it in that way. And so they truly only had the audio cue of the letter associated with the tactile pattern on their fingers, and they were able to, just using the mapping of the fingers to the dots, reproduce, 95% of the letters and the dots of the Braille cell, read them with their finger and everything, all this declarative textual information from being trained on their fingers. So that's pretty cool. So essentially we trained them to type Braille and they were able to read Braille from that, both visually and tactilely, but it's basically the same kind of translation going on. And the participants, I really saw them going like virtually typing to try to extract this information. So this is exactly what you're talking about.
Cool. Nice. Thank you.
Yeah.
Thanks, Caitlin. Does anybody else have any other questions, comments for Caitlin? Beautiful. Thanks again, Caitlin. Lovely presentation. Awesome. So according to the actual schedule, we were supposed to do like a 1 hour activity now, but I think we're like super duper late. So what I was thinking is we'll just jump and like say goodbye and end the workshop. But before ending the workshop, I just wanted to thank everybody for coming along, and I really, really hope that hope that you had a lot of fun and got a lot out of this workshop, or at least a little bit. And the other thing is just to continue our conversation outside of this workshop. We have a Slack channel set up, so I'm going to invite you all to the Slack channel, and the activity that we were supposed to do over here, we could do that later on, and we can collaborate over there as well. And especially, from your last presentation, Caitlin, you wanted a lot of collaborations out of this workshop. So you could utilize that Slack channel to collaborate with anybody that you want that has come and participated in this workshop.
Yeah, thanks, Rakesh. Yeah, I'd agree. Like, it sounds like we've got a lot of overlap going on between a lot of the people here in this workshop, and we got a cool thing going. So, like, let's. It's unfortunate that we couldn't have like the whole day workshop that we had planned originally, but yeah, let's just try to keep this momentum going. Everybody jump on Slack if you can. There's a lot of people that I would love to see like working together in the future. Yeah, so I think like yeah, this would be an awesome opportunity to get some really interesting collaborations going on and just progress this whole motor memory and HCI thing. Yeah.
Yeah. Also, this wasn't like written exactly on the website as well, but one of the outcomes that we wanted to see out of the activity was that we divide the entire workshop into like 3 or 4 groups, and we have like a speculative design session happening, and the outcome of that speculative design session would be like a journal article with those 3 or 4 speculative designs that we come up with, especially during this COVID situation where we're not able to actually do something in real. We're at least able to do some sort of speculative design. So yeah, we could potentially do that over Slack as well. And yeah, let me know your thoughts.
Just one thought. Did you mention the Slack channel in an email? Because I can't actually find it right now.
No. I'm going to send out invites right now. I've not.
Okay, perfect.
But I will also add the Slack channel details on the website as well, just so that it's there forever.
Yeah. No, I want just go ahead.
Okay, thanks. No, I just wanted to ask if you guys have any plan on trying to run a collocated workshop in the future, if this was like a one-time thing, if you're gonna try to like,
So,
gather again.
As you can see, oh sorry, this side. That's the first edition. So we are going to run the second edition. That's the plan in at CHI 2021. So
we're also hoping to get a Dashtul session.
Yeah, that's another thing. We also want to like conduct a Darkstool like a session. And yeah, if anybody wants to help with the proposal, yeah, the Slack channel will be there.
Okay, I wanted to ask if the recording will be maybe shared on Slack too, because
yes, I will do that, and I will upload that to the website and our Exertion Games Lab channel as well, if that's okay with you.
For me, yeah.
Super. Any other thoughts, suggestions as to how we can collaborate in the future before we say adios? Or how do you say bye in Hawaii, Floyd?
Mahalo.
Mahalo.
And so with mahalo, thanks Nathan and especially Rakesh for organizing this, by the way. Thank you very much.
Thank you.
And, and mahalo.
All right, mahalo everyone, and I will send the invite to the Slack channel very soon in the morning. It's almost 12 o'clock over here. All right, beautiful. See ya.
Bye-bye.
Thank you. Bye.
Thank you. Also, before everyone goes, like once you get onto the Slack channel, please share your presentations as well, just so that everybody has it. Yeah, awesome, perfect. Thank you. Bye everyone.
Bye.
Bye.
Thanks.